Hello, sir. Good morning.
Good morning. Good morning.
Yes, sir. You are audible, sir.
Is my voice is also audible?
Yes, sir. Yes, sir.
Yeah. Dr. Ajit Khojare is joined. One, Mr. Gopinath is there.
Yes, sir. Am I audible, sir?
Yeah, you are audible. The first presentation is yours only. You please be ready.
Yes,
so just I will wait for the Dr. Ajit Khojare to join.
Yes, sir.
Yes, sir. He's there. माझ्या ह्याच्यात असेल काय करायचं हो काय म्हणजे तुमचा वेट आहे बंद करू का हो
Dr. Ajit Khojare.
Sir, he's joining. I think maybe he has some lag, so.
Dr. Ajit?
Good morning, sir.
Good morning, Dr. Ajit Khojare.
Good morning. Very good morning.
Very
sir.
good morning. Okay. The first participant is already joined.
Yes, yes. Yeah, Mr. Gopinath is there.
shall we start, Dr. Ajit?
Shall we wait for some time to join the
Other
I think,
participants?
yeah, I think we have already, we passed, it is already 10. So
Yes.
it is better to start now. What do you say, sir?
Yeah, 10 o'clock. That's what I
Yeah,
got
yeah.
the information. You, as usual, you start by 10, they said.
Right, right. So
Or
shall I
we wait
start?
for just 5 minutes? So let them, the other candidates also join.
Yes, yes. Why not? Why not?
Another 5 minutes, just we'll give another 5 minutes because only one person I joined.
Yes.
Other 4 persons are there. So let them join.
Okay, sir.
Maybe they may be having some problem or something like that.
Yeah, yeah. It's online. In
online.
morning also,
Morning, yeah.
morning session, it got late. And
almost half an hour.
Almost half an hour. Right, right. Actually, technically, sometimes,
Yeah.
most of the things go very smoothly. But when problems come, we also don't able to understand what to do.
Correct.
You are not at Hyderabad or Mysore, sir?
Yeah, I am at Hyderabad.
Acha, acha, yeah. And when did you got retired, sir?
In 2015.
15, acha. It's almost 6 years.
6 years back.
Yeah. So I think resource center is a different unit of CFTRI at Hyderabad.
Just like the other departments at CFTRI, this is also, you can consider that one of the departments.
One of the department, but they have made
yeah.
it, they have located it at Hyderabad.
Hyderabad.
Yeah.
So it is for the sake of the Andhra Pradesh public.
Acha, acha. Right, sir.
We have the 3 centers right now, it is working.
Yeah.
One is in Hyderabad, one is at Mumbai, the other one is at Lucknow.
Acha, at Mumbai also there is one
Mumbai
center.
also is there.
Acha, acha. That's great.
So this we call it as the resource centers.
Yeah, yeah, yeah. Now it become the pattern nowadays to have the institute at number of places. Like NIPTEM also.
Right.
There are 2 campuses at present.
Right, right. Even recently, CFTR has opened one center at in Northeast.
Acha.
Yeah.
Right, right. That's great. Yeah.
Yeah.
And it is really needed to have that.
Really needed also.
Yeah, yeah. What's the problem with others? Why they are not joining? They are students. They are quite.
Yeah, they are students. They should be.
One of the student of mine. Shall I call him?
Yeah, please. I will also call that Beena.
Yes.
So I will ask her whether what happened to them.
Yeah, Ananta, I know him because
Okay.
he was my BTech student. No, you check in spam folder because I also got the same problem. You got the Zoom link? Acha. So you may call Miss Veena is there. Do you have her number? Shall I send you my link also? Is it possible? I think link will remain same probably.
Maybe different, I think so. That link.
Acha. Okay, try it. If you could not able to join, then call me back. So we'll find some solution. Okay. They are facing some problems, sir. I don't know.
I think so.
So I think it is already 10.06. Shall we start with one? So meantime, rest of the people can
Let
join.
them come. Let them come.
Okay. No.
Anyhow, we have to wait after the first presentation. Also, we have to wait for them.
Mr. Gopinath, how are you? I think he is muted. Mr. Gopinath, can you hear me? Okay. Hello, Mr. Gopinath.
I think ICFoST Hall itself is under mute, sir.
Oh. Yes, unmute me. Right. He just sent me the message. But who can unmute? It is not in our hand, I think.
Hello, sir. Yeah,
Gopinath. Yes. How are you, Mr. Gopinath? Good morning.
good morning, sir. I'm good. Thank you. How are you, sir?
Fine, thank you. You are the first to join.
Yes, sir.
And rest of the students are facing some problem. I think you are PhD scholar?
No, sir. I finished my master's. I'm
Yeah.
trying for a PhD admission.
Acha. And you are at IIFPT?
Yes, sir. I finished my master's at IIFPT.
And it is now NIPTEM now? It is renamed
Now
as
it is NIPTEM Tanjavur.
Acha, when you did, it was IIFPT.
Yes, sir.
Acha. Good. I think your director presentation is going on. I was just listening to him.
Yes, sir.
On architecture of food. Yeah. He's a very good speaker, I think.
Yes, sir.
So now where you are at present?
Now I'm not working, sir. I'm trying for PhD admission at abroad.
Acha.
I applied in some universities in US. I'm waiting for the result. I gave interview.
And you are the food technologist?
Yes, sir.
Acha. And now which is your native place?
Vijayawada, sir, Andhra Pradesh.
Vijayawada. You are from Andhra Pradesh?
Yes, sir.
Yes, very nice. Vijayawada has got a very nice river, I think.
Krishna River.
Krishna River. It's very big.
Yes, sir.
And COVID situation, I think it's becoming difficult for what you're striving for PhD again. No? Is there any problem from COVID also?
No, sir. No problem for COVID. For now, there is no problem.
Acha.
Now only process is going on. Review process is going on. I gave 2 interviews. I'm waiting for that.
Which university you are trying in?
University of Illinois.
US.
And University of Florida. I gave interview.
Acha.
And I applied for UC Davis and University of Georgia also.
Acha, these are all reputed university, you know.
Yes.
Still others are not. Sir, did you call Miss Veena?
Yeah, Veena, but number is not going actually.
Achha, because many
could you
people
try from
might
your side? I will
yes.
tell her number.
Yeah, I got just now. I got her call also. I will call her back.
Okay.
Yes, Mr. Anantini. You are joined, but you are not visible to us.
No. So far, nobody joined. Only we 3 are here.
Yeah, you have been. Have you entered in?
Pardon?
Hall C. Yeah. Hall C. Is it Hall C?
Hall C, it is.
Yeah, but you are not visible to us. Why not? We are visible to you, No? Acha, but your name is not appearing in the list. Whether my voice is coming through Zoom? Okay, I'm just, but I'm not sure. I will just mute you. He's saying that he joined, but he's not visible here.
Who, sir?
Mr. Anant.
Mr. Anant.
Sorry for interruption, sir.
Yeah.
He is not joined yet, Mr. Anand.
Hello?
But he is.
Hello, sir, started, sir. You can start.
But other four are not there. Only one person.
Mr. Anant, you have not joined. I think I don't know where, because I just now received.
Other four are not joined. Only Gopinath, the first person, has been joined.
Have you chosen the right link?
Ajit is there. Ajit and myself both are there. But first person Gopinath is there. So no other persons have joined in this.
You can start with him, sir. I will call the other four persons.
Okay, right. Right. Okay. Thank you. Dr. Ajit, you please start. So that's what Dr. Shivarna is telling. So he will call the other four persons and inform. Hello, your mic is mute. Professor Dr. Ajit, your mic is mute. You unmute your mic.
Yeah, he hasn't received the Zoom link. He's saying like that.
Okay. But Dr. Shivarna telephoned to Dr. Naveen Shivarna just now,
Yeah.
and asked us to start the program.
Okay. Miss Tanushri Brahme is here. Okay. Okay. So Anant, what you will try through Zoom link then? You check in spam. You must your link must be there. Okay, Zoom link, yeah. Okay. Okay, sir. So shall we start with them?
Yes, we will start.
Okay. So Tanushri here. Tanushri, am I audible to you? I think you have not been unmuted so far, probably. Tanushri Brahme?
Yes, sir.
Okay. Is my voice is clear to you?
Yes, sir.
Okay. Your voice is a little bit lower.
No, yes.
Can you just make it loud?
Now, sir?
Yeah, it's okay now. Okay, we'll start with, we were waiting for you only, and the two more fellow are expected to join. I welcome you all to this 28th ICFoST session 12, oral presentation 4. Honorable Chair, Satan Arayana sir, and here with us Mr. Gopinath and Ms. Tanushri. And two more fellows are expected to join, Mr. Eknath and Anant. So they are trying. I just called to Anant. So it is a privilege and honor to introduce our chair, very eminent scientist, Dr. Satan Arayana. I will just read his brief biodata. He was a senior principal scientist and head at CSIR's CFT RI Resource Center, Hyderabad, and he got retired over there. He is also the vice president of ICFoST Mysore. It's a great, sir, to have you having the vice president of our esteemed organization. Dr. Satan Arayana did his MSc in organic chemistry, and he was first with distinction from the Osmania University, Hyderabad. He has 35 years of experience in R&D, transfer of technology and training. he has participated in many academic activities and still participating in the activities of Sri Satya Sai Institute of Higher Learning. He has published more than 45 papers in national, international, and peer-reviewed journals. He has one book to his credit. He got 4 patents filed and 2 were commercially exploited. Very great, sir. And developed 4 technologies and all released for commercial exploitation. He has guided several students for their project work to obtain BTech, MTech, and MSc. And in the international arena, he has been deputed to UK under Indo-British program for development of agro-based industry in combined Andhra Pradesh and Maharashtra. And his area of specialization includes fruits and vegetable processing, analytical quality control of food products, techno-economic feasibility, report writing, resource survey, consultancy work, extension and transfer, technology transfer. So very welcome you, sir, and I have this privilege to introduce you. So over to you, sir.
Thank you, Dr. Ajit Khojare, for your nice words and introduction. So I welcome you all to this technical session 12 and oral presentation 4, sponsored by Measures Informa Technologies. And today I welcome the students, researchers and scholars, delegates and sponsors of this session. So first I will introduce my own co-chair, Dr. Ajit Khojare, to this forum. Professor Dr. Ajit S. Khojare is currently working as a professor and in charge UGC Community, Department of Dairy Science and Technology, Vivekananda College, Samarth Nagar, Aurangabad. So he is obtained his MTech Dairy Engineering and obtained PhD is NFP Fellow, ICRA Holland. His research and professional experience, he has started his career in 1996, and up to 97, he was worked as a deputy officer, Gokul Milk Project. Later, he has shifted as a research associate to National Dairy Research Institute, Karnal, India. Up to 2001, he has worked, and 2001 to 2002, he has worked as assistant professor, Maharana Pratap University of Agriculture and Technology, Udaipur, and 2002 to 5, as assistant professor, Maharashtra Animal and Fishery Science Universities. Then 2005 to 18, he has worked as assistant professor, Department of Dairy Science, Vivekananda College, Dr. Baba Saheb Ambedkar, Marathwada University, Aurangabad. So 2018 to 21, as associate professor, Department of Dairy Science, Vivekananda College, Dr. Baba Saheb Ambedkar, Marathwada University, Aurangabad. In the same now, from the October 2021 onwards, he is the professor and in charge of the same department and same university. And he is high at his credit. So he has worked in so many committees and other things in the different as a chair and conducted the different seminars and symposiums. At his credit, so many awards are there. So few I want to mention here. So he got an award for excellence in social educational work, Guru Smruti Award in 2007, and he has also got the Maharashtra Government Open Merit Scholarship holder in 1992. And he got the Honorary Vice Chancellor Special Appreciation Certificate, MAFSU, in 2004. And he is a NFP International Fellow at ICAR, Netherlands. So these are the few. And apart from this, he got many prizes and awards in by submitting the research papers and presenting these papers in different seminars and other things. So he has delivered invited talks more than 18 in various conferences, seminars, symposiums, etc. So he has published 27 papers in national and international journals, in the peer-reviewed journals. 27, more than 27 he has published peer-reviewed journal. And at his credit, 4 books and chapters are there at his credit. And he is also having one process at his credit, technology development for manufacture of ready-to-use Srikhand mix. So this is a wonderful product and a very famous product of the Maharashtra. And he has successfully guided the 3 MTech students to for their dissertation work for obtaining the MTech. And also he is guiding the PhD candidates. So one PhD candidate have already registered under his guidance for obtaining the PhD degree. So he got the international fellowship that I already told, NFP International Fellowship at ICRA, Wageningen, Netherlands. So his area of specialization are dairy and food engineering. He has also developed a lot of videos, lectures in the dairy and food processing industries. Very nice, sir. So you are very dynamic and young professor in the field of, especially in the dairy science and the food science. So it is my honor to introduce to this forum.
Thank you, sir. Thank you very much.
Thank you. And with this brief introduction about co-chair. So today in this technical session, 5 participants are presenting their work as a oral presentation. Mr. Gopinath Mummuleti is from IIFT Tanjavur, presenting on the production on leaven from the low-cost substrate and its characterization. The second candidate is Dr. Pinky Saina, Center of Food Technology, Science Faculty Campus, University of Allahabad, Prayagraj, Uttar Pradesh, presenting on her talk on enhancing micronutrient content and antioxidant activity of barnyard millet through lactic fermentation. The third person is Mr. Eknath Shinde from the College of Food Technology, Vivekananda, Vasantarao Nayak, Marathwada Krishi Vidyapeeth. He is VNM KV Parbhani, submitting his research work and presenting his research work on the development and quality evaluation of the protein and energy-rich oilseed NutriBar. The fourth person is Miss Tanusri Brahme from Pune, refractance window dryer, novel drying technology. The last person is not least. So this is Engineer Anant Dhotre from the ICAR National Dairy Research Institute, Bengaluru, on the Thermo mechanical cutting machine for frozen blocks of butter. So with this, I request Mr. Gopinath to present his presentation, oral presentation. Over to Gopinath.
Yeah, shall we tell them the time frame also, sir?
Yeah, it is, sir, 10 minutes. We are giving you to each candidate 10 minutes each. So please, Gopinath, complete by within 10 minutes of the time you are presenting.
Sure, sir. Am I audible?
Yes.
Can you see my slides?
Yeah, it is there.
Very good morning to everyone, respected chair and co-chair and all the participants. First of all, I would like to thank AFSTI for giving me this opportunity to present my research work. Today, I'm going to present on production of leaven from low-cost substrates and its characterization. This is our research team. The research was conducted at IIFPT Tanjore under the guidance of Dr. Suresh Kumar, Department Head of Food Biotechnology, IIFPT. Coming to brief introduction, leaven is basically an exopolysaccharide composed of fructose. The leaven polysaccharide is produced from sucrose-rich substrate by the action of leaven sucrase enzyme. It is produced as exopolysaccharide by different types of bacteria and fungi. Its properties includes antioxidant activity, anti-cancer activity. It is highly soluble in water and it has film forming capacity, and it is highly stable at high temperature and pH. And in coming to food applications, as it is a polymer of fructose, it can be used as a sweetener because of its wide range of properties. It can be used as a stabilizer, thickener, and we can produce edible films out of it. And it can also be used as encapsulating agent for drugs in pharmaceutical industry. The increase in demand for the natural ingredients and increase in awareness among the consumers for the natural ingredients, we thought of working on natural ingredients. So we took this topic as our research project, and particularly leaven polysaccharide was selected because from many years, leaven polysaccharide is naturally produced by various bacteria. From commercially, it is produced from synthetic fermentation medium rich in sucrose. Very few studies were conducted on low-cost production using alternative substrates, and very few, like one work was done on using molasses, and one work was conducted using sugar beet. So we thought of producing this leaven polysaccharide using low-cost substrates, and the low-cost substrate we selected was coconut inflorescence sap. Why we selected coconut inflorescence sap is due to the coconut inflorescence sap or coconut nira, though it has very high nutritional values in terms of macro and micronutrients, there is lack of awareness among the consumers regarding the nutritive value of coconut nira. So it is consumed in only in rural areas. So various preservation techniques were developed, but could not able to commercialize this coconut inflorescence sap due to the natural fermentation by yeast, which is very rapid, and it produces ethanol in very few hours, within 2 to 3 hours. Yeast start producing ethanol. So lakhs of liters of coconut nira is getting wasted every year due to lack of consumption. So we thought of using this coconut inflorescence sap as a fermentation substrate for the leaven production, as it is rich in sucrose with around 172.31 gram per liter of coconut nira. This is the whole process, fermentation and precipitation process we followed for the production of leaven polysaccharide. We collected the fresh coconut inflorescence sap in the early morning, and immediately it was autoclaved, and fresh culture of Bacillus subtilis was used as a culture medium for the production of leaven polysaccharide. The autoclaved coconut inflorescence sap was adjusted with the pH and then inoculated with the Bacillus subtilis culture and incubated in the shaking incubator for 24 hours. After incubation, the fermentation was done to remove the Bacillus subtilis, and then the fermented medium is added with ice cold ethanol to precipitate out the leaven polysaccharide. The leaven polysaccharide, the crude leaven polysaccharide is purified using dialysis membrane, and the pure polysaccharide was precipitated out from the fermentation medium, and it was air dried at room temperature and kept for storage and used it for the further studies. This is the experimental design we used. Like we took 3 independent variables as a fermentation parameters, like temperature, pH, and the shaking speed or agitation speed. We designed the experiment between 30 to 40 degrees centigrade temperature, pH 5 to 8, and 120 to 180 RPM agitation speed. Using central composite design, design was made, and the highest leaven polysaccharide was produced. Produced was 51.84 gram per liter at the optimized condition of 35 degrees centigrade temperature, 6.5 pH, and 150 RPM agitation speed. And modeling was done, and quadratic equation was developed to predict the leaven yield at different concentration, different conditions. And after optimizing the fermentation conditions, the precipitation process was optimized. After fermenting the coconut inflorescence sap, the fermented medium was adjusted with adjusted with the pH from 5 to 12 and checked for the highest maximum leaven yield at what pH highest leaven was precipitated out. We observed highest leaven was precipitated out at pH 10 with the yield of 54.45 gram per liter. Further, by using different solvents also, we optimize the fermentation, optimize the precipitation process. At pH 10, we used 4 different solvents: ethanol, isopropanol, and methanol at 1:2, 1:3, 1:4, and 1:5 ratio for the precipitation of leaven polysaccharide. And we got highest leaven yield of 56.49 gram per liter with ethanol at 1:5 ratio. And estimation of time of maximum leaven yield. All the experiments till now were conducted for the time of 24 hours fermentation period. But to know at what particular time interval maximum leaven is producing at the optimized conditions, the experiment was conducted and leaven was observed at different time intervals. We observed that at 20 hours of time interval, we got highest yield with 57.2 gram per liter. And to further increase the yield of leaven polysaccharide, we used a fed batch fermentation process by feeding the fermentation medium with 2 grams sucrose in one set of experiments. And in one set of experiments, we used 1.5 gram sucrose and 0.5 gram yeast extract to know whether only sucrose, like carbon source, is affecting the leaven yield or even the nitrogen source also. We observed that both the sucrose and nitrogen source were affecting the leaven yield, and we observed the maximum yield of 62.1 gram per liter. And effect of natural fermentation. Coconut nira, as I said before, it ferments very rapidly at room temperature immediately after tapping from the coconut. So when we go for the commercial scale, every time we may not able to autoclave the tapped coconut inflorescence sap immediately after tapping. So we stored the coconut sap at different time intervals at room temperature, and then we autoclaved, and we observed at till what time interval we can delay the autoclave process after tapping. We observed that after 12 hours of delay, complete ethanol was formed, and there is no leaven formation in the sample, and there is no significant difference in the leaven yield up to 4 hours. And further, the characterization of leaven polysaccharide was done with the thin layer chromatography, and we observed and confirmed that leaven is composed only of fructose. And further, FTIR analysis was carried out to evaluate the structure of leaven polysaccharide produced. The 2929 centimeter inverse wave number correspond to the carbon hydrogen stretch, which is the fingerprint region for the fructose molecule, and the glycosidic linkage corresponds to the 104181 linkage centimeter inverse wave number corresponds to the glycosidic linkage, and remaining wave numbers corresponds to the pi rounding of the fructose molecule. And we also did CNMR and HNMR to further evaluate the chemical structure of the leaven polysaccharide, and we observed C2 carbon with the 104.45 ppm spectrum was the fingerprint region for the fructose molecule with beta glycosidic linkage. And further, HNMR was carried out and evaluated the hydrogen atoms of the leaven polysaccharide. And to further increase the leaven polysaccharide yield, we used other substrates like molasses and pineapple extract. We made different ratios of molasses, coconut inflorescence sap, pineapple extract in combinations and in alone. And we maintained the sucrose concentration at 168.99 plus or minus 4.63 gram per liter, and conducted the experiments, fermentation experiments. We observed that the molasses, coconut inflorescence sap, and pineapple extract combination got higher yield with 69.1 gram per liter of leaven polysaccharide. And this was the highest leaven yield apart from the synthetic medium, this was from natural substrates. This was the higher yield observed till now when compared to the previous studies. And further, the polysaccharide produced at different with the different substrates was characterized using FTIR and confirmed the leaven polysaccharide. And the molecular weight of the leaven polysaccharide was analyzed with gel permeation chromatography, and we observed we have three different peaks of molecular weights. We have three different peaks, and high molecular weight and low molecular weight leaven polysaccharide was produced together. And thermal stability was studied using differential scanning calorimetry, and the leaven polysaccharide was thermally stable even after 300 degrees centigrade temperature. And water solubility index and water holding capacity was studied, and it was observed that leaven is highly soluble in water with 89.42% with and water holding capacity of 112.61%. And the strong antioxidant activity was also observed with the leaven polysaccharide. It showed 100% inhibition with the free radical DPPH free radical scavenging activity at 1200 microgram per ml. And in vitro anti-inflammatory activity was also studied, and we observed 100% anti-inflammatory activity inhibition at 500 microgram per ml concentration of leaven polysaccharide. To evaluate the safety of leaven polysaccharide on mammalian cells, we used a hemolytic assay to study the safety issues of leaven polysaccharide on mammalian cells, whether it has any degradation activity on cell membrane of the mammalian cells. And we observed that there is no cell membrane disruption with the leaven polysaccharide, and it was 100% safe to use on mammalian cells. And antimicrobial activity was also studied, and the leaven at different concentrations using well diffusion method, and the leaven showed antimicrobial activity against the pathogens such as Listeria, Salmonella, Staphylococcus, and E. coli. And finally, coming to the application, we used the leaven polysaccharide as a icing sugar replacer in the cake cream instead of icing sugar replacer.
In my so I don't know, it is not responding something. So just if anything is there, you please interact. If everything comes, then I will join. Don't wait for me. There's some problem. Right, sir. Thank you.
The leaven polysaccharide was used as a icing sugar replacer by replacing the icing sugar with the leaven polysaccharide at different.
Mr. Gopinath,
yes, sir.
Can you summarize it, because other speakers also need time?
2 minutes,
Please.
almost done. Almost done, sir. And the sensor evaluation was conducted, and we observed that P3 sample with 25% leaven polysaccharide and 75% icing sugar got highest intensity of the sweetness intensity was observed with the 100% leaven polysaccharide. It confirms that the leaven polysaccharide is more sweeter than the icing sugar which we use commonly. And P3 sample with 25% leaven and 75% leaven and 25% icing sugar got higher overall acceptability. And concluding the research work, the molasses, coconut inflorescence sap, and pineapple extract combination can be a best alternative source for the leaven polysaccharide production. And the optimum fermentation conditions were 35 degrees centigrade temperature with 150 rpm agitation speed and initial pH of 6.5. And Bacillus subtilis can produce maximum leaven within 20 hours compared to other organisms, which will take at least 7 to 10 days to produce the leaven polysaccharide. Compared to other organisms, Bacillus subtilis growth was very rapid and produce a high amount of leaven polysaccharide at very less time. And the leaven polysaccharide has a very good antioxidant, anti-inflammatory, and antimicrobial properties, which makes it helpful in various applications in food and pharmaceutical and even in cosmetic industries also. And leaven can be a best alternative source for the natural icing sugar or sucrose, which can help in reducing the calorie intake. And apart from this, various other health benefits like anti-cancer activity, prebiotic activity, and anti-AIDS activity was also observed with the leaven polysaccharide in previous studies. So it can be a best natural ingredient in food processing. Thank you.
Thank you, Mr. Gopinath. Thank you very much. And we will have the question answer session at last, as Chair told me. So we have the very short of time, and we have to move forward. So I request to next speaker, I think Dr. Pinky Saini, whether she is available.
Sir, am I audible to you, sir?
Yes, sir. Yes, sir. You are.
Yeah. So
Please go ahead, sir.
Yeah, no problem. You if you want, you can interact with Gopinath on his presentation. And if you want to ask him anything, you please go ahead. And one more person, that Eknath is not joining.
Yes, yes.
He is not willing to join in this one. So only 4 candidates are there, sir.
Yeah, there is one more. Magdalene Franklin had joined. Magdalene, Miss Magdalene, can you hear my voice? Hello.
Yes, sir.
Are you a speaker? Hello.
Sir, my student will be presenting, sir, Dr. Anand Dotre.
Acha, right. Yes. Okay. So, I thought because some 2 students have not joined, probably of them you might have joined. So you are welcome, Miss Magdalene. Yeah. So Pinky Saini is not there. So Mr. Eknath Shinde is not there. Tanushri Brahme is here. Tanushri, can you start with? Yeah, sir, we can have question and answer session at last, as we discuss. Satyanarayan, sir.
No problem.
Because we already have the paucity of time now.
Right. Okay. No
okay, sir. Okay, sir. Tanushri Brahme, go ahead.
Yes, sir.
Yeah. Start your presentation, please.
Wait.
Present your screen.
Is it my screen is visible?
Yes.
No,
we can.
it may come at any time.
Yeah. Try to make it brief, better, because we have the shorter time.
Yes, sir. I am trying.
Okay. You made it in a presentable form. Yeah. It is now in whole screen.
Okay. Shall I start, sir?
Please go ahead.
Okay. Welcome to all. Myself, Tanushri Brahme. I am from School of Food Technology, MIT, ADT University, Pune. I am going to present on reflectance window dryer, novel drying technology on drying of puran using cabinet drying and reflectance window drying for batch process. So first we will see what is drying. Drying is the commonly described as the operation of thermally removing water content to yield a solid product and prohibit the growth of enzymes and bacteria. There are some drying methods like sun drying, hot air drying, infrared drying, solar drying, freeze drying, dry electric drying, and tray drying. So we will use here cabinet tray drying. So cabinet tray dryers are used for batch drying of solid food at small to moderate scale. They are inexpensive and simple to construct. Cabinet dryers are frequently found in rural installation where they are used for drying of fruits, vegetables, and herbs. Air inlet temperature are usually in the range of 60 to 80 degrees Celsius. Depending on the product and the condition, the duration of the batch is typically 2 to 10 hours. There are some disadvantages like it required more times, efficiency is low, and nutrition losses. In reflectance window drying technology. A reflectance window dryer, a better approach to preserve a visual appearance of dried product and nutrition content. Heat treatment causes degradation of color, and in drying operation, product is directly contact with the heated surface. But in this drying process, the product is not directly contact with heating medium. Due to that, the color of reflectance window dryer dried product had better quality. Reflectance window dryer have energy efficient heat transfer technology. It can save energy and it has property to self-regulate as the material dries, which means the heat damage is kept to a minimum and minimize nutrition losses. This is a 3D diagram of reflectance window dryer for batch process. In methodology, we will use here Puran. Basically Puran is used for making Puran pudding. Puran was prepared by the methods like first with clean chickpeas split was soaked at 30 degrees Celsius for 2 hours to absorb maximum water. After that, soaked chickpeas split were cooked at 100 degrees Celsius for 10 to 12 minutes. Sorry. In cooked chickpeas split, jaggery was so
Take some water.
Yeah, Tanushri, you take your time. Oh, don't worry. You have water.
Take some water.
Yeah.
sorry, sir.
Are you well, Tanushri?
Yes, sir.
It's all right. You take your time. No, don't worry. Yeah. Be comfortable.
In cooked chickpea split, jaggery was mixed in the 2:1
You
ratio.
increase your. I think your voice is very less. Audio. You increase your audio.
Is not comfortable.
I'm not sure whether
Right
it
now-
is because it is now okay.
So okay.
Yeah.
In cooked chickpea split, jaggery was mixed in the 2:1 ratio. And again, cook for 5 to 6 minutes to melt the jaggery. Grind it for 2 minutes. Then finally we get the puran. In methodology, puran is first kept on the polyester film. Then hot steam is passed, which removes the moisture present in the product. And it is the exhale out with the help of exhaust and final dried product obtained. When the puran is placed on the plastic membrane surface, the water is in the puran creates a window that allows for the passage of infrared energy through the material. This is the moisture content graph. Reflectance window dryer has a time taken low as compared to the hot air dryer. In physiological properties, there is no significant difference observed between the cabinet dryer and reflectance window dryer. In color value, we need a lightness color more. So hot air dried puran had dark color as compared to reflectance window dryer. During hot air drying, there is a heating because of that there is a Maillard reaction that causes browning and darkening of the product. In case of indirect heating of reflectance window dryer, there has no heating and product become lighter, having the lightness more as compared to the hot air dryer. There is a we will see here puran dried at hot air drying and reflectance window dryer at both temperatures in 50 degrees Celsius and 60 degrees Celsius. In conclusion, the least time required in reflectance window dryer as compared to cabinet dryer for drying of puran. The proximate component unaffected by both the drying methods. The moisture content and water activity found less in reflectance window dryer than cabinet dryer. Because of the porous structure, reflectance window dryer Boron found higher rehydration ratio, moisture absorption, and solubility index. The thermal energy is carried out by the circulating water transmits sensible heat through the film to the food material. The refractory window dry system is suitable for dehydrating moist material in the term of time and energy. Thank you.
Okay, good. Even though a lot of constraint you have presented your talk.
Extremely sorry, sir.
It's all right. You tried well, despite your health is not supporting you. I think you are suffering from cold.
Yes, sir.
Yes, yes. It's all right. Sir, shall we go for next speaker?
Yes, we will go.
Okay. I think Anant.
Yeah, maybe the Anant.
Okay. Anant, you can share your screen. You go ahead, please. Anant? You unmute yourself first. Unmute yourself. Anant, your voice is not reaching to us. Please. Yes.
Hi, yes, sir. Actually, my unmute was not enabled. Now I could. Yes, sir.
You can present, please.
Yes, sir. Sir, is my presentation visible?
Yes, yes. Please go ahead.
So, at the outset, I thank AFSTI and the organizers of this committee for giving this opportunity to present our research before this learned audience. And I welcome respected chairman, co-chairman, my fellow speakers and other delegates of this conventional for this presentation. So, sir, this shall I proceed, sir, with your kind permission?
Yes, yes, please go ahead.
So this basically my work was on thermomechanical cutting machine for frozen blocks of butter. As we all know that India is the largest producer of butter, we contribute around 6.1 million metric tons of butter in world's production, which stands at 11.13. So this is more than 50% of the total butter production. Now, mostly this butter is subjected to frozen storage in the forms of blocks of 20 to 25 kg. And these blocks require to be frozen and stored below 20 degrees centigrade. At the time of consumption, all these blocks need to be essentially molten before it can be used for any purpose such as making ghee, making butter oil, or use in the preparation of recombination of milk. All the existing system in the industry take minimum 8 to 9 hours of melting time for these frozen blocks of butter, which includes 6 to 8 hours of thawing, followed by 30 minutes of size reduction, and then the final melting starts, which is accomplished in next half to 1 hour. This process is very long and it encounters a lot of contamination problem, and there are a lot of time dependent energy losses associated with this system. So it has been a long lasting problem with the industry. Many attempts have been tried in NDRI and other institutes, but because of one or other reason, they were not to the mark. And when therefore we took up this study and with a aim to follow a different kind of approach in order to develop a machine. So this present study was basically aimed to develop an equipment which would cut the frozen blocks of butter without thawing them. And we basically divided the course of work in 4 phases. The first phases, we undertook the quantification of the properties of butter as a function of temperature, which was never done before, which included, these properties included physical properties, thermal properties, and rheological properties, which combinedly affect the cutting properties of the butter. We quantified all these property and then took these properties as input parameter for the CFD simulation of temperature distribution inside the butter and its thermomechanical cutting dynamics. Based on the results of this simulation, we designed and fabricated a machine for which will cut the blocks of butter using thermomechanical actions, and at last we evaluated the performance of that machine. So as a part of first phase, we can see that the density, thermal diffusivity, thermal conductivity, and other properties were evaluated. The most of the properties of the butter, as we can see here, the density did not follow a linear relationship with the temperature. Same was the case with thermal diffusivity and thermal conductivity. Both had a non-linear relationship with the temperature in the studied range of temperature from -30 to +30 degrees centigrade. Then we also evaluated the specific heat of the butter as function of temperature using differential scanning calorimetry and integrated that data obtained in to get the enthalpy temperature relationship for butter. This helped us to get the a little bit of linearization of the specific heat of the butter over the temperature. Then the cutting force of the butter blocks was evaluated by using texture profile analyzers, and the viscoelasticity of the butter was evaluated using the Anton-Power rheometer. The results of both these tests concluded that butters undergoes a rapid and remarkable structural change at 10 degrees centigrade, and it undergoes nearly melting at 37 degrees centigrade, which were a crucial finding for our further course of work. Now, based on these quantification of the properties, we converted all the data in the form of equation, and those equations were fed for the CFD simulation of temperature distribution inside the butter. We can see here the setup that we use for the simulation of temperature distribution and the results on the right side of the screen. So we marked melting point of butter as a crucial parameter in this simulation, and which was helpful in deciding the size of blades that we were going to use in our machine. So this is a glance of result that we obtained for temperature distribution. At the time proceeds, we can see the temperature profiles broaden and the melting regime advances slowly. So based on this temperature simulation, we got how the cutting of the butter will advance if we keep the temperature of butter at specific level, and this helped us to decide that the blade thickness of the butter should not be more than 20 mm, otherwise the cutting process will be greatly hampered. So based on the results of this simulation, we prepared a conceptual design considering the loading orientation of the block as shown on the right side. We identified different parts of the machine and performed the engineering calculations for each part, which included the structural frame, length of the blade, thickness of the blade, the loading plate on which the blocks are to be loaded while feeding into the machine, then the calculations for pneumatic assembly, which included the selection of pneumatic cylinder and designing and development of a pressure plate. Then we perform the heat requirement calculations in order to decide the power requirement of the heating blades that are also going to the blades which are going to insert or penetrate into the block of butter in order to cut it. So after that, we had to decide the exact design of the blade. For that, we selected 3 blade geometries having circular, diamond shape and wedge shape cross sections. Each geometry with a thickness of 8, 10 and 12 mm was subjected to mechanical simulation considering a simple simply supported beam, and we studied responses in the form of minimum factor of safety and a maximum deflection of 2 mm was permitted. So based on the results of this mechanical simulation and the factor of safety, a cutoff factor of safety of 2.5, finally we selected a circular cross section geometry for the blade. Then we performed the simulation with actual thermomechanical dynamic cutting. Here we can see that we compared and we got 3 different results, that in which condition how the cutting time will be different. So this helped us to decide the thermomechanical cutting parameters for the machine, and based on these we decided the experimental trials and also fabricated the work with finalization of all the design components. So here are some of the glimpses of the fabrication work that we performed in engineering workshop, which included performing different machining operations. And this is the final design of the machine. I have also shown the control panel, which had a specially designed instrumentation circuit based on PLC. It consisted of temperature measuring devices, digital analog module, thyristor as an actuator, then human machine interface and multifunctional meter to tap the energy consumption and temperature profile during the cutting process. These are the glimpses of the experimental work, and here we can see how the cutting blocks are obtained. This is the second picture is the indication of block being fed, and third picture in the video we can see how finely we are getting the cut blocks. And then we optimize the performance of the machine in terms of the cutting time, which was the main focus of the study. So we used full factorial design, and the results of the analysis indicated that the cutting time was mainly affected by block temperature, blade temperature, and the pressure applied, and a combination of block temperature and applied pressure. Similarly, the study of main effects indicates how each parameter will perform if we studied it by keeping the other factors constant. The interaction effect was also quantified. Similarly, the energy consumption of the machine during the cutting operation was quantified, and it indicates that the energy consumption was greatly affected by the block temperature, which was the most energy consuming factor. Followed by that, it was affected by blade temperature, and at last, like least, was the interaction effect between the block temperature and the blade temperature. Here we can see the main effects and interaction effect plots for all the studied parameters. So based on the statistical analysis using this full factorial design performed in Minitab, we came out with 2 optimal solutions for operating the machine. One optimal solution for when we use the frozen blocks of butter without thawing, and second optimal solution was for the blocks of butter when they were thawed to a temperature of 10 degrees centigrade. So we can see that we could cut, and when machine was operated under optimized condition, it could cut the block of butter within 12.53 minutes, which was a significant upgradation over the existing systems adopted by the industry.
Please conclude your talk.
Yes, sir. The melting time of the butter was found to reduce from 37 to 14.3 minutes, which was a significant reduction. And finally, the economic analysis was done, which indicated that the unit offers 25 to 30% of energy saving over the conventional method. So in conclusion, we can say that the developed thermomechanical block cutting unit could successfully cut the butter blocks without thawing, which was the aim of the research. It produces a throughput of 2,394 kg of butter per day. The developed machine takes nearly 56% less time as compared to the existing system and consumes 30% less energy. The other features of the machine or it is easily scalable to higher capacity, and it is amenable to automation, which is a requirement of today's industry. In present form, the machine can be readily adapted by small and medium scale ghee makers in India. Thank you, sir. I thank my major advisor, advisory committee, and the director of NDRI for guiding as well as helping for getting this work patented. Thank you, sir.
Good. Thank you. Thank you, Anant. What about this Pinky, Dr. Ajit?
Yes, sir.
Is Pinky is available?
I don't think so, sir.
Yeah. So
Pinky and Eknath, they are not available.
Eknath already.
We have called them earlier also, but
yes.
I don't know what's problem with them.
Magdalene, now shall we invite the Magdalene?
She is a guide of Mr. Anand, sir.
I see. Okay.
Yeah. So we welcome her to this session also. It is nice to have guide also.
Right. Okay.
Yes, we can start the question answer session, sir. If you could start with.
Yeah. To Anant, my question is, you have already taken a patent for this cutting machine. What is the cost of the machine actually?
Sir, in laboratory, it costed us nearly 4 to 5 lakhs, sir.
4 to 5 lakhs,
yes.
Including the CNC, everything.
Pardon, sir?
Including the monitoring of the controlling conditions.
Yes, sir. Yes, sir. Including the controlling circuitry.
Okay.
You got the patent or filed?
No,
the
sir.
patent?
No, sir. We have just filed it.
Yeah.
It has not yet been granted.
Not yet granted.
Yes.
Are you given it to anybody for commercialization so far?
No, sir. Actually, this work has just completed. I am yet to get the award of degree.
Okay.
So it will take some time for and I think as per the rule of NDRI, after going through some committee only, it can be commercialized or it can be transferred. The technology can be transferred.
Okay.
So it is very first time I am presenting it before a scientific community.
Okay. Dr. Ajit?
Yes, sir. Anant, if you have filed the patent, do you have any restriction to present it before the scientific committee? Is
no,
it allowed?
sir. No, sir. Once we have filed, no issue, sir.
No issue. Okay. Very nice work you did. I congratulate to your guide and you for this wonderful work. I have just few questions that I hope this fine cutting has not been achieved because there were some particles spreading. I was seeing in the video. There is no any fine cut is an issue in the machine.
No, sir. Actually, fine cut was not also aimed for.
Achha.
Because actually at the end of cutting, we have to subject all these butter blocks for complete melting. So basic objective is to cut the blocks in order to expedite the melting.
But you are heating the cutting blade at the time of cutting the butter.
Yes, sir.
So butter is in frozen condition and that cutter itself get heated by some external source at that time.
Yes, sir. Yes, sir.
Okay. Very nice issue. I never noticed that issue when I was working in butter, when I was in Gokul Milk Project. Yes. So we were having one cutting machine, but I was trying to recollect that what was the problem with that. And have you tried with the cow and butter, buffalo butter separately, whether their hardness value is same in both the butter?
No, sir. Actually, in laboratory, I have tried in initial for quantification, but for actual experimental work with the machine, we procured the butter blocks from the industry. Usually, we get a difference of cow butter and buffalo butter, but buffalo butter is little harder. As
yes,
compared
because
to,
of the fatty acid composition. Right?
Because of fatty acid composition, sir. And so we visited the Bangalore dairy, which is a renowned plant there, and we visited their butter melting section. So existing system, it is adapted all over India, which consisted of hot pipes carrying water. But it took more than like 40 minutes, and it cannot handle the frozen butter. That is the major lacuna with all the existing systems. So we wanted to eliminate that thawing time, because it is considerable time. It takes 6 to 8 hours. One shift, the butter blocks are kept outside of the cold store. So that we wanted to eliminate. And
okay, very nice work. Shall we go to Mr. Gopinath, sir?
Yeah,
Yeah.
we go. Mr. Gopinath?
Yes, sir.
Yeah, my question is to you is, because these leavens are using, you said that it is in the as a sweetener, stabilizer, and as edible film. Any FSSAI specifications are there for leaven, and is the FSSAI is approved for this particular product used in the food?
I don't know about the FSSAI approval, sir, but it has FDA approval.
FDA approval is there.
Yes, sir.
Okay. Good. And what will be the cost of production of leaven?
Commercially, when synthetic medium is used with the synthetic sucrose, it will be costing around like the process which we followed, the batch process which we followed. If we use the same process, it will be around 9,800, sir, per kg. When we use this low cost substrate, it was almost more than 50% reduction was there. It was around 4,600 rupees.
Okay, very good, very good. Dr. Rajit?
Yes, sir. Mr. Gopinath, very nice presentation you gave us. You said it is a source of leaven. You have used the coconut, huh?
Coconut inflorescence sap, sir. Coconut vira.
And the main source of leaven is sucrose?
Yes, sir. From sucrose, microorganism will ferment and it will produce the leaven polysaccharide.
And which drying method you have used to get that leaven?
We dried at room temperature, sir, because it is very sticky kind of thing. So if we whatever, like if we go for freeze drying also, immediately after freeze drying it will become sticky again, because it is very highly hygroscopic. So under controlled conditions we have to freeze dry the product. So we just followed the normal air drying process at room.
Air drying.
Yes,
so you use the air dryer, or you kept it at
the room temperature? We kept aside,
as
sir,
such for the how much duration of time?
Around 20 to 24 hours.
But if it is hygroscopic and if you kept it like that, then again the moisture in the atmosphere might have affected.
Under controlled closed conditions, we tried to dry it actually. Previous studies also conducted like that only, sir, using air drying only, because as it is very sticky, like we can't even go for spray drying also, because nozzle will block. And if we go for tray drying or something, the caramelization will happen. Color is changing. So
it is highly temperature sensitive like that.
It is stable up to 300 degrees centigrade, but a color change was there, sir. Bit degradation and caramelization is browning is happening.
Right. Okay.
So you can only go for freeze drying.
Don't hesitate to put some problem also, because all the time it is not like that in research. We do something and it is totally successful. We can have certain, in conclusion also, we can have one line of this problem we were facing, and that can be the further input for the next researcher like that. Okay, very nice.
We majorly focused on production, sir.
Yeah.
We wanted to focus on
that work can be done, right?
Yes, sir. We wanted to focus, but because of lockdown and all, we could not able to continue so many work.
Yes. So Tanushri is there? Tanushri?
Yes, sir.
Yes, sure. Are you feeling well now?
Yes, sir. Feeling better now.
Satyanarayan sir, you may go ahead, please.
Can you dry in your window dryer even though a material is thermoplastic in nature?
So your voice is breaking. Can you please repeat again?
Can you by using your dryer, is any thermoplastic nature material also can be dried?
Plastic. No, sir. I'm using here a puran, a traditional dish,
Okay.
because it is in puriform, so it is easily applied on it.
Mhm.
She hasn't tried for any other material, I think.
Okay. Okay. No, no problem. Okay.
Yes.
Now, what will be the cost of drying per kg or something in your that particular product?
So this reflectance window wrap for the batch process is near about 45K,
Okay.
45,000, sir. Cost.
Have you calculated?
Yes, sir. Just like different parts, like I have calculated on the behalf of that. Total amount is 45,000.
Good. Dr. Ajit.
Yeah, Tanushri, you appears from the Pune. From which institute you are?
Sorry, School of Food Technology, MIT University. Pune.
Achha. And is it your MTech work or like that?
MTech work, sir.
Is it completed?
No, sir. I'm pursuing now.
Achha. From where you got this name, refractance window dryer? I never heard of. But you mention about the tray drying only.
No, sir. I have searched on it because on the market level, only continuous continuous equipment are available. So I'm trying to it for the batch process.
Achha, but how you got this name, refractance window dryer? Because this name looks very wonderful. But you talked about tray dryer only. How you justify this name?
Sir, on the Google or a research paper, I have tried some research on this dryer. So I have got this for the continuous process. So I thought that, so if it is available in continuous process, so why not in batch process?
But still, I could not get answer for this name, refractance window dryer.
Yeah.
Okay, it's all right.
It is there, sir. Already it is there. Refractance.
It is there.
It is already there. Literature, in the literature, it has been already reported. Some of on the name of the refractance window dryer. So
it is like a tray dryer only.
It is like a tray dryer, but only thing is
Yes,
he has arranged to drag the moisture on the top of that one, and it is speed up the
vacuum operated.
Not completely vacuum, but it absorbs the evaporated moisture also, drag, and faster dryer when compared to the.
But why they use the word refractance?
I don't know that what is the.
It means okay.
But,
yes, Anant, you want to say something?
Yes, sir. If may I add, like, actually, sir, am I audible?
Yes, please go ahead.
Sir, that name has come from refractive, like index. Because it takes into account both, like we are using the radiative energy of the heating medium also. The surface through which the on one side of the surface there is a media, and other side of the surface there is the product to be dried. So in all the cases we get only the heat in the form of convection or conduction, but here the surface used is transparent. So we are tapping the radiative energy, and when that from that word refractance, it has come from that, like refractive index.
Yeah. Tanushri would have shown us the photograph of that dryer, then it would have been more clear to us. Okay, it's all right, sir. Please go ahead.
Yeah, I thank all the participants for their wonderful presentation, and they have also enlightened us on some of the aspects. So very much thankful to all the speakers. I thank my co-chair also for supporting me and also conducting this session very efficiently. I am thankful to the AFSTI and also 28th ICFoST organizing team for giving me the opportunity. And I wish all the best for the participants for their work and future purpose. Thank you very much. Thank you, sir.
Okay. Thank you, sir. Thank you all, please.
Thank you, sir.
Thank you, sir.
You may leave now.
Sir, we will close the session. Then I
We will
will
close and then we can discuss.
I will contact you on over phone.
Okay, sir. Okay, sir.
Right?
Okay, sir. Bye. Thank you very much.
Hello, Swathi, can you hear me? Hello.
Yes, ma'am, we can hear you, ma'am.
Okay, this is the right session where I am supposed to be because I have received several minutes meeting link. So I thought,
Yes, ma'am.
yeah, this is where we have the session. I have a session with Dr. Prashant.
Yes, ma'am.
Okay.
Dr. Harish Prashant KV.
Yes. I'm
Yes, ma'am.
waiting for him so that we both can plan together today's session and how we can go about it. Yeah, so I will be able to unmute myself, right?
Yes, ma'am. You are co-host now.
Okay, thank you so much.
Yes, ma'am.
Hello. Dr. Shalini, can you hear me?
Yes, sir. Very good afternoon. I can hear you.
Good afternoon, Dr. Shalini. So how are you?
I'm very good. You are Dr. Prashant?
Yes.
Okay. Very nice to meet you, sir. Thank you so much. So I wanted to, just ask you how much time we are going to give to the students, because as per the list, we have 5 students. Oh, 5 presenters, sorry.
Yeah. So if all the students have already joined, I'll just what we'll do is we'll give each person 8 plus 2. Okay.
10 minutes.
Yes, 10 minutes. 8 minutes for their presentation, and a couple of minutes, 2 questions from my side, 1, and from your side, 1.
What about if audiences want to ask?
Actually, we cannot have a question from the audience.
Not audience, but in the meeting itself, there are some people.
I think that can be passed on to the respective presenters later on for answering those queries.
Sounds good.
Okay. And if the presenters are there, basically the evaluation will be mainly on original research data.
So we have to do the evaluation as well?
Not right now. I'm just telling the students. Okay. Dr. Arya, I'll call you later on after this. Okay. We'll talk those things later. Okay. But I'm just mentioning these points are been taken care for evaluation. One is the original research data which they'll be presenting, and conclusion of the part of the work which they're going to present, and time efficiency, the clarity, and of course how they'll answer the questions. Okay, is it fine with not much time? Shall we proceed? Dr. Shalini, over to you now.
Yeah. Yes, sir. Thank you so much. So shall I start? Is it meeting is recorded? Okay.
Yes.
So, yeah. Very good afternoon to everyone. A very warm welcome to all the presenters as well as all the audiences and food technologists over the country. I welcome all of you in today's technical session. So I, Dr. Shalini Arya, would like to introduce today's chairperson, Dr. KV Harish Prashant. Dr. Harish is currently a senior scientist at Functional Biopolymer Laboratory at Department of Biochemistry, which is at CSIR Central Food Technological Research Institute, Mysore. And Dr. Harish has more than 20 years of research experience at various levels. But apart from being a very active researcher, Dr. Harish has been involved in many other activities, including he has been an advisor to many other universities, including with Health Welfare Department of Government of Karnataka. And he has been bestowed upon various awards and accolades. He was also previous year in 2020-21 honorary secretary of FST headquarter, and also at many other organizations similar to FST, like Society of Biological Chemists and Association of Carbohydrate Chemists and Technologies, and others. So to name few awards and accolades that he has received, like from AIFPA, he received Dr. M. Mahadevian National Award with a silver plaque. Also, he received Best Faculty Researcher Award from Chitin and Chitosan Society at my very own institute, that is Institute of Chemical Technology. And also recently in 2020, he received Institutional Best Publication Award. And he has many research publications published in standards of high repute and patents, and he has developed technologies. So, a very strong biodata. And if some of you would like to collaborate with him, his area of specialization is in neurotoxicity, neurodegeneration, tumor biology, and other lifestyle disorders like diabetes and relative interventions of particularly dietary functional polysaccharides in respective amelioration. So it's very nice to have you here in this session, and I feel very fortunate to be with co-chairing this session with you, sir. So thank you so much, and over to you.
Thank you, Dr. Shalini. Even the pleasure is mine being with you to conduct this session. Before going exactly into the session, I'll just want to introduce our co-chair, Dr. Shalini Arya. She is currently Assistant Professor of Food Technology at Institute of Chemical Technologies, that is ICT Mumbai. And she is a member of Executive Committee of Global Young Academy, member of Indian National Young Academy, INSA, recipient of various international awards, including TWAS Fellow, Malaspina International Scholar, Best Presenter Awardee, Best Innovative Idea Presenter Awardee, National Awardee like AFST Young Scientist Award, Best Thesis Award. So there is a lot of award she has been bagged. And along with that, she has published around 80 research articles, that is publication wise, and she has around citation of more than 1,300 and H index of 18. So with that's of a high repute, and she Dr. Arya works especially in the area of Indian traditional foods. That is her very speciality, and she also works with waste utilization and bioactive extraction using green techniques and non-thermal processing for retention of especially the bioactives in the food is a very important area of research. And Dr. Arya and her research group have developed Indian traditional food products having low glycemic index using low cost and locally available ingredients. Dr. Shalini has handled a lot of research projects with more than 2 crores per project like that, and she has guided around 60 master tech students as well as 80 PhD research students. So Dr. Shalini has delivered more than 50 invited lectures on national and international platforms. She is also an active science communicator and actively engaged in science outreach activities on national as well as international. I think she has been a very active researcher along with the other activities too. So with this short biodata of Dr. Arya, we'll directly go to the session. So first, I'll call upon the first presenter, Mr. Raman Kumar. Raman Kumar, I think, are you there? From CSR IHBT?
Yes, sir, I'm listening.
Okay, can you please share your slides and go with the presentation? Okay.
Okay, sir. Okay, sir.
As I told you, it is a 8 + 2 minutes. So you restrict to the time, and you all the best to you. Thank you.
Okay, sir. Thank you, sir. Good afternoon, everyone. Am I audible?
Yeah, very much audible. Please go ahead.
Okay. Good afternoon, everyone. Myself, Raman Kumar, pursuing my PhD in algal biotechnology. Today, I'm going to present on the topic microalgae fortified functional foods, a potential approach to combat protein and micronutrient malnutrition. According to WHO, 1/3 of the world's population is suffering from iron deficient anemia and protein deficient malnutrition. According to NFHS data 2016, in India, 38% children and 53% women were severely affected from anemia and malnutrition. Malnutrition comes with another burden such as stunting, wasting, and loss of immunity. As you can see in the slide, the red regions are showing the increasing trend in malnutrition. So, question is, after so many efforts of last 5 decades, why we are still far away from the solution? Because the conventional methods includes supplementation of externally fortified foods with synthetic salts. They have a major drawback with poor oxidative stability and side effects such as acidity, constipation when consumed. The another option is to increase the consumption of micronutrient rich plants and green vegetables. They are also facing problem of lower biomass turnover and presence of anti-nutritional factors. Therefore, we have identified some gaps in the treatment strategies, such as low bioavailability of iron and a need for ready-to-eat formulations with high shelf life and lower cost. In this context, we proposed the microalgae as a source of micronutrient and combating malnutrition. Spirulina is a WHO approved and a GRAS approved edible algae, which has a major application in food sectors. It is also a rich source of protein, antioxidants, and micronutrients. Algae biomass do not have anti-nutritional factors such as phytic acid and oxalic acid. Apart from nutritional benefits, it is also a potential industrial feedstock. That means it can be cultivated in agricultural non-productive lands using non-potable waters. It has 3 to 4 times higher photosynthetic efficiency compared to terrestrial crop plants. It is easily scalable, therefore no problem for the biomass for a large population of India. So we propose three products with the Spirulina fortification. First one is a ready to reconstitute sattu. Second one is ready to eat energy bar. Third one is ready to cook wheat bulgur. Locally it is called as dalia. For wider public acceptance and outreach, Spirulina must be supplemented in traditional food formats. Nutritional quality evaluation of the Spirulina fortified foods were performed according to standard AOSC protocols. In results, we found that the average protein content ranges between 15 to 20%, and the total iron content ranges between 9 to 55 mg per 100 grams. In general, we can reach up to 25% of protein and 50% of iron if we consume daily our food products. To validate the general health claims offered by Spirulina platensis, we performed in vivo bioefficacy of food products by iron and protein repletion methods in Sprague-Dawley rats. In this study, casein and ferrous ascorbate were used as a reference protein and iron source respectively. This is the detailed experimental design in which first we fed the rats with the iron and protein deficient diet for 4 weeks, and later we have recovered the rats with our food products. Our results are promising in terms of increase in hematological parameters such as hemoglobin and total serum iron content, as well as we found the significant decrease in stress marker MDA. Antioxidant enzyme superoxide dismutase is also found increased when compared to the iron deficient diet. When it comes to histopathological alterations occur due to the anemia and malnutrition, such as accumulation of fatty droplets in liver and degeneration of villi structure in intestine. When we fed the rats with our food products, we found reversal in histopathological alterations. This is the graphical summary of the whole experiment, in which we can see that Spirulina inhibit the reduction in hematological parameters as well as serum markers and reverses the histopathological alterations like fatty accumulation, thinning and scattering of myocardial muscle fibers, and degeneration of villi. I would like to conclude that the products had good acceptability score in sensory analysis. The maximum inclusion level of Spirulina ranges between 3 to 5%, and the Spirulina supplementation could be an effective strategy for combating micronutrient and protein malnutrition. I would like to acknowledge CSR for granting the finance. I would like to thank Director for providing facilities. Special thanks to my supervisor and co-supervisor, Dr. Vidya Shankar and Dr. Vikram Patyal, for guiding me during the whole experiment. Thank you.
Mr. Raman Kumar.
Yes, sir.
Are you audible?
Yes.
Can you hear me?
Yes, sir. Yes, sir.
Actually, when you go for the feeding the animals,
yes, sir.
How this the mouse model reacts to your feed, because since Spirulina is a little pungent in their smell, and so how do it reacts?
Sir, the maximum inclusion level is 3 to 5%. So they don't show. So they don't show the like they don't feel a bad odor or something like that.
So there is nothing, and as for the work you have carried out, so still a lot of pending work is still remaining, right?
Like, sir, what type of work?
Actually, what you have presented the data
yes,
with
sir.
respect to that.
Yes, sir. Yes, sir. Feed conversion ratio and the PER ratio, everything is not showing in this presentation.
You have carried out.
Yes, sir.
Okay. Thank you. Dr. Shalini, over to you.
Yes, thank you so much, Raman. It's an interesting piece of work, but yes, as Dr. Prashant mentioned, it is like a preliminary work and there is more data needs to be generated. I have a very basic question. What about the bioavailability of the protein from Spirulina, because it is now very well established that it has a very poor bioavailability due to presence of other anti-nutritional factors. So are you going to, evaluate that as well?
Ma'am, Spirulina does not contain any anti-nutritional factor, and we perform the PDCAS analysis that shows a higher digestibility quotient also.
Okay, what about heavy minerals that makes it unavailable? Did you also done the analysis?
Toxicity studies shows that there is no toxic symptoms in the rats, and we have also performed gut microbe analysis for the
your data. What you have in the next slide is not statistically analyzed. Have you done the statistical analysis? Because in
yes,
any research it is very important, and I cannot see any
yes, ma'am.
statistics. You have done the statistical analysis. Okay, thank you, sir. Thank you.
Oh, thank you, Mr. Raman Kumar, and all the best for your PhD. Okay, thank you for your sharing your work with us. Next speaker is Ms. Swathi Mudball from Delhi. Ms. Swathi. Can you hear? I think you should unmute yourself, and can you please present?
Yeah, she is now unmuted. Yes, Swathi. I think there is some internet problem with her because, yeah. Swathi, can you speak? No, we cannot hear you, beta. Okay, so Swathi, I think you will have to, adjust with the audio system. Maybe use some external audio. So meanwhile, can we move to the third participant?
Yes, I think so, because we'll
By the
be
time
running
Swathi
out
goes
of
on.
time. Yes, I think if the Ranjita Gracie, yes, Ranjita Gracie, next speaker. Meanwhile, Ms. Swathi, can you able to just check with yourself your audio, and by the time this another person's completes, you can rectify your technical problems at your end. Okay.
Swathi, can you speak? Can you hear? Oh, we cannot hear you. Yeah.
Hearing her.
Is Gracie is going to present?
Okay, please start.
Ranjita Gracie?
Yes, ma'am.
Yeah. Your voice is very feeble. I hope you will be more audible later.
Are my screens visible, ma'am?
Your voice is not heard properly. You start first.
I can't even hear anything. I couldn't hear.
Hello.
Yeah,
Hello,
Ranjita. Yeah, be little louder, because your voice is very feeble.
Yes, ma'am. Yes, ma'am. Good afternoon, everyone. It is my pleasure to share the research outcomes on the topic atmospheric pressure pin to plate cold plasma for the rheological modification of guar gum. Myself, Ranjita Gracie. I'm working under Professor Uday Annapure in ICT Mumbai. Hydrocolloids like guar gum are well known for their rheological properties, and because of which they are used as functional ingredients in many applications. Apart from that, they are very good sources of hydri fiber. In fact, guar gum is studied to give higher butyrate production in the cut. But because of its nature of giving high viscosity with minimal concentration, it is restricting its usage at very high quantities in food products. So this indeed requires a modification. Also, such modifications in the hydrocolloids will open up new opportunities in terms of food applications. Existing modification techniques like enzymatic methods, chemical methods, genetic methods have their limitations in terms of process requirements and discharges, residual discharges, and also for their non-feasibilities. So this demands a green, sustainable, and eco-friendly modification technique like a cold plasma processing. Cold plasma, we all know about cold plasma, that it is a partially ionized neutral gas consisting of different dynamic and reactive species and free electrons. So what happens when we subject the hydrocolloids in cold plasma environment? Different reactions expect to happen, such as the surface etching phenomena, or depolymerization of the polymer, or cross-linking, or oxidation of polymer. This could change the rheological as well as structural characteristics of polymer into a required way. So the present work aimed to study the effect of atmospheric pressure pin to plate cold plasma on the rheological attributes of guar gum. So the study uses a pin to plate plasma system having a bottom plate electrode and a top pins electrode, and the distance between the electrode was kept constant, but the operating voltage and the treatment time has been varied from 170 to 230 voltage and time of 30 to 60 minutes. The voltage and the time has been decided based on the preliminary studies and the system constraints. Treated guar gum was made into a dispersion and majorly focused to study the rheological modifications, both in terms of rotatory rheology as well as oscillatory rheology. And also, what happens exactly to the guar gum after plasma treatment has been investigated through different analytical techniques, which I will be speaking about in the later slides. First of all, talking about the steady shear flow behavior, when the guar gum dispersion was sheared in between parallel plates, viscosity was continuously decreasing, which is the actual nature of the guar gum. That is the shear thinning behavior. After cold plasma treatment, as is observed in the graph, the trend in the behavior has not been changed. However, the apparent viscosity of the guar gum has been modified significantly after cold plasma treatment, especially at the extreme voltage and time condition. So the behavior of the fluid has been fitted with our model, and the model was best fitted with the R-square value higher than 0.9. Also, the pseudoplastic nature has been evident by seeing the flow index values of lesser than 1 in all the fluids. However, viscosity at 50 per second has been reduced from 800 centipoise around to 300 centipoise. It is a drastic reduction. This could be the result of depolymerization of guar gum after cold plasma treatment. The other parameters such as the flow point, crossover frequency mentioned in the table will be discussed in the later slides. So now we understood the overall viscosity of the system is affected after cold plasma treatment, but we know the guar gum dispersion is not a completely viscous solution. Rather, it is a viscoelastic system. So we try to analyze the viscous as well as the elastic modulus properties after cold plasma treatment. The solid lines represent the elastic modulus, that is the solid-like behavior of the fluid, and the viscous modulus, that is the liquid-like behavior of the fluid. Because it is a gel, the solid-like behavior is over than the viscous-like behavior, and at a particular point of shearing, the gels will convert from a solid-like behavior to a liquid-like behavior. That is, the flowability will increase. And that particular point is called the crossover frequency. And the crossover frequency of the polymer tells about the relaxation time taken by the polymer after a deformation. More the crossover frequency, higher will be the relaxation time taken. That is, higher the stability of the gels. So it is observed from the graphs, the crossover frequency of plasma treated guar gum dispersions, especially at the 230 volt 60 minutes, was higher than the controlled guar gum dispersions. This tells about the strength of the guar gum gels after cold plasma treatment. Also, the flow point. Here also, flow point tells about how much shear rate is required to break the gels. So higher the strength of the gel, higher will be the shear strain required. So because cold plasma depolymerizes the guar gum, the strength of the gel is reduced, thereby the flow point of the gel reduced from 88.7% to 62.8%. However, at 230 volt 6 minutes, there is no transition found. The gel was almost like a liquid. Then I would try to study the thermorheology of the guar gum. That is, what happens to the guar gum viscoelastic properties at varying temperature ranges. So I have subjected the dispersion from 25 degrees Celsius to 80 degrees Celsius, and then I have again dropped down the temperature to 10 degrees Celsius to study about the recovery nature of the dispersion. As it is clearly seen, because of the weakness of the gels, the elastic as well as the viscous modulus were lesser over the temperature range for the plasma treated samples compared to the control samples. However, the varying viscoelastic behavior was lesser over the temperature range. This tells about the thermal stability of the gels. So based on these rheology analysis, we have understood that cold plasma is able to modify the guar gum to give weak as well as a stable gel. And I've tried to study the structural changes of guar gum after cold plasma treatment with FTIR. However, there was no major changes in the pattern of spectrum observed from FTIR. All the fingerprint regions of pyranose rings, uronic acids, and OH were found to be similar in all the plasma treated as well as control samples.
I think you have to conclude.
Yes,
Your
sir.
time
Yes,
is.
yes, sir. Two more slides, sir. Yes, sir. Yes, sir. So, but the molecular weight of the guar gum has been significantly reduced from 7% to 50% at an extremely higher plasma treatment conditions. That is 230 volt to 60 minute. However, pH was reduced because of carboxylic group production of oxidation and the absorption capacity of water to oil. They were also increased because of the surface etching phenomena. So, I would like to conclude that the synergetic effects of depolymerization, oxidation, as well as surface etching effectively modify the guar gum rheological and structural characteristics. This would facilitate in application of geriatric formulations for extreme populations which cannot consume high viscous products. There, how we can supplement high fiber content in their formulations. These are some of my references. Thank you so much for the opportunity.
Thank you, Ranjita. I think Dr. Shalini, if you have a quick question, you can ask.
Yeah, Ranjita, very nicely presented. Yeah, tell me, what is the application of this low viscous, you said geriatric food, but do you have any idea about what are other techniques which also causes depolymerizations, and whether this technique is cost effective, commercializable, and can handle a large quantity of sample?
Talking about the scaling up aspect of cold plasma still in its lab processing level only. However, cold plasma is widely applicable in textile industries. If scaling up would be easier in textile industries, it would be possible in food industries also. We hope for the future. But considering cost parameters, capital cost of the system is indeed high. Agreed. The processing cost is related to other non-thermal technologies. As you have asked,
I think
yeah, your voice is not audible.
Your voice is breaking. I think thank you once again, Ranjita Gracie, for your presentation on cold plasma, especially with respect to modification for guar gum. And I think we can go to the next speaker. I think Miss Swathi Mudball, is your technical problem solved? Can you able to present now?
Swathi, unmute. Yeah, unmute yourself.
Yeah, if it is not there, next is Miss Shilpa from CSIR CFTRI. Are you there?
Yeah, Shilpa is here. Shilpa, could you unmute yourself?
Yes, ma'am.
Great. Please share your slide.
She is also coming. Swathi Mudball is also. Doctor.
Please, start your presentation, Ms. Shilpa.
Rohit, Swathi Mudball is logged in as Nartinder Singh. You have to tell her that after Swathi, she should put it.
Yeah. Swathi, you can try, speaking, unmuting yourself so that we understand if your problem is solved. Can you speak, Swathi?
Yes, ma'am. Hello.
Yeah. Perfect.
Okay,
perfect.
then you start presenting, okay?
Yeah. If you are
sorry,
able to...
Shilpa, I think you can wait for another 10 minutes so that we can hear from Swathi, and please start.
Sir, can you see my slides?
Not yet. You haven't shared. You are audible perfectly. You have to share. There is a green button at the center.
Air spring.
स्लाइड का
डाउनलोड
वो यार कहाँ डाउनलोड सेव नहीं की वही तो बात है सेव नहीं करोगे
Yes, Swathi, we can, the screen is appearing.
Yes, ma'am. I'm trying.
Yeah, it is. Now we can see your desktop. Now open your PowerPoint presentation.
Yes, ma'am.
यहाँ पे ओपन नहीं की हुई आपने
सर वहां से
डाउनलोड्स
Make it in the presentation mode.
Yes, ma'am.
Or you can just press F5 button.
कहाँ पे शेयर होगी शेयर
यहाँ शेयर का ऑप्शन
ये हो तो गई है शेयर आपकी नहीं
Is share here on the top above, tab button, there is a insert, na? There.
Yes,
yeah, perfect. Go ahead. Thank you.
Good afternoon, everyone. My topic is development and quality evaluation of brown rice noodles prepared from basmati and non-basmati rice varieties. Rice is widely consumed crop. Rice is categorized on the basis of aroma, basmati and non-basmati variety. Generally, rice is consumed after removal of bran as a milled rice, though rice has high nutritional value. Since whole brown rice grain contain high level of nutrients such as protein, lipid, mineral, vitamin, and other bioactive compounds such as oryzanol, tocopherol, tocotenol, as compared to milled rice. Demand of brown rice has increased. However, brown rice can't meet the consumer expectation because of poor texture and poor palatability. The demand for gluten-free product is also increasing, and rice milling industry is looking for new way of utilizing brown rice. Therefore, the objective of my was development and utilizing an evaluation of noodles made from brown rice obtained from basmati and non-basmati rice varieties. 8 varieties were procured. 8 varieties were procured. Out of them, 4 were basmati and 4 were non-basmati. Then dehusked them and obtained brown rice, and brown rice were milled by using laboratory scale milling machine. Proximate analysis were done and functional properties were done of brown rice flour obtained from basmati and non-basmati varieties. These are the list of proximate analysis, and these on the right hand side, these are the list of functional properties of brown rice flour. And then statistically analysis were done. Preparation of brown rice noodles. Modification of starch of native tapioca starch was done by using heat moisture treatment. Noodles were made by using brown rice flour, modified tapioca starch, xanthan gum, edible oil. Dough were made with hot water, approximately 60 ml, and dough were kept for 10 minutes at room temperature. Then sheeting was done. Noodle was slit, steamed for 50 seconds, and dried at 45 degrees Celsius for 12 hours and stored for further analysis. Cooked noodle were evaluated for Hunter color parameter, cooking properties, glycemic index, starch hydrolysis, and sensory properties. Now moving on to the proximate and functional properties of brown rice flour obtained from basmati and non-basmati varieties. These are the proximate and functional properties. Now, as you can see the average difference between non-basmati and basmati variety very clearly. L star lightness index is higher in non-basmati varieties. However, A star and B star is lower, which indicates higher ash content in basmati varieties, protein content, dietary fiber, blue value, forming capacity, water absorption capacity, oil absorption capacity. And out of all the variety, PB 1121 showed the highest protein content, dietary fiber, blue value, which indicates amylose content, and functional forming capacity, water absorption capacity, and oil absorption capacity. And these results will reflect in noodle making properties also. This is the pasting profile of basmati and non-basmati rice flour by rapid Visco analyzer. This is very interesting data. As you see, the pasting viscosity of basmati rice is lower than the non-basmati varieties, which may be due to the other factors attributed by dietary fiber, protein content, and ash content. Protein viscosity, pasting viscosity, breakdown viscosity, and final viscosity not only depend upon the amylose content, but also attributed by dietary fiber, protein content, and ash content. Next, pasting graph of basmati and non-basmati rice flour by rapid Visco analyzer. As you can see, the temperature increases, gelatinization temperature increases. This is the PR121 is non-basmati variety, which is showing high pasting profile, high setback viscosity, high final viscosity. On the other hand, PB1121 showing lower pasting viscosity, setback viscosity, and final viscosity, which is, as I earlier mentioned, due to the presence of high dietary fiber, protein content, and ash content. This is the amino acid profile run by HPLC. As you can see clearly, PB1121 basmati rice showing the high essential amino acid, namely arginine, valine, histidine, isoleucine, leucine, lysine, threonine, tryptophan, methionine, phenylalanine, as compared to non-basmati varieties. Basmati varieties also showed higher aromatic components such as phenylalanine and tryptophan than non-basmati varieties. Basmati varieties also showed higher content of aspartic and glutamic acid, which contribute to sweetness and umami taste in the rice, apart from 1-acetyl 2-pyrrolene. Next, moving on to the phenolic acid profile of brown rice from basmati and non-basmati variety done by HPLC method. As you can see, gallic acid, ferulic acid, 4-hydroxybenzoic acid are higher in basmati varieties as compared to non-basmati varieties, but transferulic and picomeric are lower in basmati varieties than non-basmati varieties. And this phenolic acid is directly linked to the antioxidant capacity. This is the parameter of Hunter color parameter and cooked noodle parameter. Color, I have prepared 8 variety noodles from basmati and non-basmati. As you can see clearly, PB1121 showed the higher lightness index, which clearly show the acceptability to the consumer. Lighter the color, better the acceptability. And cooked noodle, I have tested the gruel solid loss and water uptake of the cooked noodle. PB1121 showed the lower amount of gruel solid loss, which means during cooking it gives a minimum loss in the water. Leaching of ingredients will be less during cooking. And PR129 showed the maximum amount of gruel solid loss, which is directly we can relate with the rheology. Now moving on to the rheology property. As I had earlier discussed, the water uptake was optimum for PB1121 and gruel solid was minimum. So the rheology also tells the same. Storage modulus of PB1121 rice cooked noodle were higher than the PR129 non-basmati rice noodle. And this is the starch digestibility of cooked noodle prepared from brown rice. This is the graph, starch hydrolysis versus time. This starch digestibility tells about how much time product will take by the body to get converted, to get digest into the glucose. PB11 1121 noodles were took least maximum time to get digested. That means its GI is low. And on the other hand, PR121 showed the maximum GI. And it took maximum GI means high hydrolysis index. And all the statistical data and analysis data supported the sensory data as well. And in the sensory profile also, PB1121 showed the maximum acceptance. Now I would like to conclude my research. Nutritional and rheological and noodle making property clearly reflected the Basmati variety were better than non-Basmati varieties for application in gluten-free noodles. Among Basmati varieties, PB1121 had higher dietary fiber and amylose content, resulted into noodles with lower hydrolysis index and glycemic index. Noodles developed were gluten-free and had lower glycemic index.
Thank you, Dr. Swathi. Thank you.
Thank you. Thank you, sir and ma'am.
Question for you. Whether the phenolic acid content, whatever you want to look at it, how did you carry it out? What was the process you involved for extraction?
Yes, I took the brown rice flour, and then 80% methanol and extracted twice. And then rotavapor were used to evaporate the methanol, and then what we call it, the
cooked rice, or it is for the raw rice?
Sir, this is for the raw rice. Hello.
And what happens to this profile?
Hello. Yes, sir.
What happens to this profile if it is cooked?
Sir, it will get lower down. Phenolics will get lower down because during cooking, phenolics decreases.
Thank you. Thank you. Dr. Shalini, do you have any question?
A quick question. Swathi, if the phenolics decreases, how the glycemic index decreased? Because before cooking and after cooking, that means, your glycemic index is decreased.
Yes, ma'am.
Cooking.
There are other factors.
But phenolics are already decreasing, and generally dietary fiber, phenolics, if they are decreasing, that means
because of the retrogradation of this starch, GI was decreases because the PB1121 I showed the lowest amount of glycemic index. On the other hand, it had the highest amount of amylose content, which may get retrograded during cooking. And other factors also I have showed in proximate analysis. It had high protein content and dietary fiber also.
What about the texture? Noodles are generally expected to have that elastic texture, but in case of your sample, which is gluten free, did you face any difficulty? Where is the texture analysis data?
Yes, ma'am.
Where is it?
Yes, ma'am. I tested.
You did not do texture?
Yes, I performed texture analysis, but due to the lack of time and but I can show. I have made the slide too for that in case.
Okay, no problem.
Yes, ma'am. Here is the texture data. Like PB1121 showed the highest firmness, as you can see on the slide. This is supplementary data I have made.
Yeah, you should also had control data, like how control. So you don't have a control. So control could be, this is your gluten free. So with gluten. So ideally it is made from with gluten. So you should have had that control data also. But anyway, good kind of a good piece of work. Congratulations. Thank you so much. Over to you, sir.
Yeah, thank you, Ms. Swathi. And I think with no delay, we can now move on to Ms. Shilpa's presentation. Ms. Shilpa, now are you ready with your slides? Can you please share and start presenting?
Yes, make it in presentation mode. Yeah, perfect. Thank you.
Yeah, good afternoon all. I am Shilpa HN from Pundicherry Department, CFTRI, Mysuru. The topic of my presentation is concentration of anthocyanin by forward osmosis process. To begin with, let's have some basic fact about the osmosis. Osmosis is nothing but the movement of water molecule from lower concentration to the higher concentration to the semi-permeable membrane. The difference between forward osmosis and reverse osmosis is that in the forward osmosis, the osmotic pressure gradient between the feed and raw solution will be the driving force for the process, whereas in the reverse osmosis, the external pressure we will apply for the movement of the water molecule from the lower solution to the higher solution. Forward osmosis is a non-membrane as well as non-thermal driven process which uses the semi-permeable membrane to concentrate the liquid food at ambient temperature without product deterioration. The driving force is the osmotic pressure gradient between the raw solution, that is the solution of higher concentration, and the feed solution, that is a solution of lower concentration. It is a low energy consumption process which has the capability to concentrate the liquid food up to the 60-degree Brix, and it also has the higher capacity to retain the thermolabile compounds. The aim of the study is extraction and concentration of the anthocyanin from the rose, that is damask rose, Rosa damascena, and the hibiscus flower, which is Hibiscus rosa chinensis, by forward osmosis process. The methodology includes the shade-dried flowers of rose and hibiscus were used for the anthocyanin color extraction. To extract the anthocyanin color from these flowers, we have used the citrate phosphate buffer at pH 4.8 with a dilution ratio of 1:20 at 30 °C temperature for 4 hours. As the forward osmosis process is a water-based separation process, we need the water-based solvents. So we have used this extraction parameters based on the standardization. These standardization parameters are standardized based on the anthocyanin content concentration. After extracting the anthocyanin color from these flowers, we have run for the forward osmosis. In the forward osmosis, a forward osmosis unit having the flat membrane module was used, which has the membrane area of 1.14 into 10⁻⁻² per meter square. The feed, that is rose and hibiscus anthocyanin extract, and the draw solution, that is 6 molar sodium chloride was used, and the flow rate were fixed at 150 ml per minute, and the feed and draw solutions were circulated around the either side of the membrane through peristatic membrane to peristatic pump. Here the feed volume will be 0.5 liter, which is 500 ml. That wise that of the feed was this raw solution, that is 1 liter raw solution we have taken. The raw solution used was 6 molar sodium chloride. The result shows that in the first graph you can see this is the change in the water flux versus time. The process was start with the flux of 13.5 liter per meter square per hour to it end with the 6 liter per meter square per hour over the 7 hours. The possible reason for the change in the water flux from 13.5 to 6 is due to the concentration polarization. It is nothing but the buildup of the concentration of the non-permeable particles in the feed due to the movement of the permeable particles through the membrane. The second graph, that is B, it shows that the concentration of the anthocyanin by FO, this extract is from the rose. Here we can see that initially the anthocyanin content of the rose is around 190 milligram per liter. It is in cyanidine 3 glucoside milli equivalents. After 7 hours, it has increased to 12 folds. That means from 190.91 milligram per liter of anthocyanin content, it has increased to 2128.04 milligram per liter. And also along with the anthocyanin content, the TSS of the extract was also varied. The TSS varied from the 1.2 degree Brix to the 14.5 degree Brix. That means the 12 folds of the TSS change was also found in the rose extract. Whereas in the hibiscus extract, the anthocyanin content of 329.08 milligram per liter initially from 1 hour, it has changed to the 3021.18 milligram per liter. while the TSS of the hibiscus extract from 1.6, it has increased to 17.1 degree Brix. That is in the row. From this, I can conclude that in the rose anthocyanin extract, the FO has resulted in concentration of 12 folds. That is from 0.5 liter of extract, it has resulted in 41 ml, whereas in the hibiscus, the FO resulted in 10.7 fold of the concentration. That is from 0.5 liter to the 47 ml. Where in terms of anthocyanin content, in the rose, it has concentrated from 190.91 milligram per liter to the 2128.05 milligram, while in the hibiscus extract, the anthocyanin has concentrated from 329.08 milligram per liter to 3521.15 milligram per liter. So from this, I can conclude that forward osmosis is a more suitable method to concentrate the liquid food at ambient temperature without any product deterioration. Thank you.
You, Swathi. Sorry, Shilpa. Ms. Shilpa, like what was the driven force which you have taken hibiscus for this cyanin, anthocyanin? See, what made you?
The osmotic pressure gradient between the draw solution and the feed solution. Here I have used the feed as a hibiscus anthocyanin extract, whereas the draw solution will be 6 molar sodium chloride solution. The osmotic pressure gradient between those two will be the driving force.
Dr. Shalini.
Yeah, Shilpa, these anthocyanin pigments are very sensitive to pH and then also to the environment, oxygen. So, do you think the quality of the pigment will remain as it is, similar to control, or it will be degraded while you apply it in the food samples? Did you do similar kind of, stability studies?
Actually, ma'am, we have checked actually compared to the other thermal methods like evaporation and other concentration methods, these forward osmosis has reduced the degradation of the anthocyanin, like compared to thermal methods.
But did you study the stability?
No, ma'am. Still it is on.
But you haven't done, then how can you claim that it is better than other techniques? In terms of retention, would you like to say?
Like, ma'am, compared to the thermal concentration using the evaporation, the retention of the anthocyanin will be more in the forward osmosis concentration than the thermal process.
Yeah, quantity I understood. I was asking about quality. Anyway, thank you so much, Shilpa. Nice work and all the best. Yeah, over to you, sir.
So, Dr. Shilpa, actually that was a nice this thing. Because even I was wondering how come that stability will be retained. Nevertheless, we'll move on to the next speaker, Mr. Pramod Kumar from CSR CFI. And please, Mr. Pramod, you can present, you can share your slides and you can start presenting.
Pramod, can you talk so that
are you audible, madam?
Yes, perfectly audible. Please share your slide and present yourself.
Okay, madam.
Perfect. Go ahead.
Good afternoon, everyone. My name is Pramod Kumar, a PhD scholar at Biochemistry Department, CFRI, Mysore. First of all, I would like to thank ICFoST for giving this opportunity to present my work. My research title is Chitosan Derivatives, Amalgate, Neuronal and Behavior Defects in Retinol-Induced Drosophila melanogaster Model of Parkinson's Disease. In earlier studies, it was shown that Parkinson's disease is a neurodegenerative disorder that affects the motor and cognitive function caused by a genetic and environmental factor. And also it was estimated that around 4 million people are affected by Parkinson's disease worldwide. and its prevalence will increase further as the population ages increases. The pathogenesis of Parkinson's disease still it is unknown, but increase the evidence suggests that oxidative damage may contribute to the neuronal loss in the Parkinson's disease. Rotenone is a common neurotoxic pesticide used for the development of experimental Parkinson's disease model, which causes neuronal death and apoptosis. And also the loss of dopamine level in the brain causes the Parkinson's disease symptoms such as stiffness, shaking, and difficulty in moving. Chitosan is a natural polymer generally obtained by enzymatic and chemical deacetylation of chitin. Various molecular weight of chitosan derivatives has been pointed out as one of the ingredients in the food additives due to its various biological activities such as immune enhancing, anti-tumor, and neuroprotective effects. Chitosan and its derivatives like LMWC can penetrate blood-brain barrier and inhibit the excess of ROS production that caused by a neurodegenerative condition. Based on all this literature survey, we thought that chitosan derivative would change the course of Parkinson's disease. Hence, we framed the objective of this study was to show the effect of LMWC intake on rotenone-induced neurotoxicity to understand the mechanism involved in the development of Parkinson's disease in Drosophila melanogaster. LMWC was extracted from the native chitosan by patented derivatization process using KPS. And rotenone was used as a Parkinson's disease in one of the best animal model, Drosophila melanogaster. Obtained LMWC was fed for 7 days for rotenone-induced flies, and behavior and biochemical parameters were assessed. Initially, mortality of rotenone was carried out. A different concentration of rotenone were fed with the diet for 7 days and to get the IC50 value. We found that 50% of the mortality was occurred in 500 micromolar concentration of rotenone. For the treatment study, 2 concentration of LMWC, that is 5 mg and 10 mg, were chosen by pilot studies to reduce the mortality rate caused by a LC50 concentration of rotenone. As a result, around 60% of the mortality was reduced in high concentration of the LMWC used. Further, survival studies was carried out. Initially, rot fed for 7 days and toxic induced flies were transferred to fresh media in the presence and absence of LMWC. As a result, we found that LMWC significantly extended the survival rate until 19 days in low concentration and 28 days in higher concentration. Further, as I told, loss of walking behavior was observed in Parkinson's disease patients. In the present study, locomotor behavior of flies were assessed using climbing and walking assays. As a result, a reduce in the climbing ability was observed in rotenone-induced flies. Interestingly, our LMWC enhanced the climbing ability and increased the walking velocity of the flies. Further, after 7 days treatment, flies head and body were separated, homogenized, and used for the biochemical analysis. Initially, we have checked the oxidative markers such as reactive oxygen species, hydroperoxide, and protein carbon level in head and body of the flies. As a result, there was an increasing all this activity of this marker were observed in rot alone treated group, whereas co-treatment with LMWC, all these markers normalized to normal level. Hence, this result suggests that LMWC show the protective effect against rot-induced oxidative stress in Drosophila melanogaster. Further, antioxidant activities such as catalase, superoxide dismutase, and GST activities was analyzed. As a result, rot increases these enzyme activities, but co-exposure of LMWC reduce all these activities level to normal level, and also flies fed alone with LMWC did not show any changes in the in these parameters. Further, based on literature survey, we found that rotenone is a directly inhibit the mitochondrial complex and increase the reactive oxygen species level in Parkinson's disease patients. In the present study, we evaluated the electron transport chain enzyme activities. We found that decrease in the NADH and succinate cytochrome C reductase enzyme activity in rot alone treated group. With the co-exposure of LMWC increases these activities in rot-induced flies and suggests that LMWC may be part associated with the neuroprotective effect. Further, ATP and MMP activity was assessed. These markers are indicated for mitochondrial activity, which reflects the process of electron transport. As a result, we can clearly see the decrease in the ATPase level in ROT alone treated group. But co-exposure of LMWC enhanced this ATPase activity. Further, mitochondrial membrane potential level was analyzed by rhodamine fluorescent dye method. In the result, the higher amount of fluorescence value indicate that lower membrane potentiality. As a result, we can see here the increase in the fluorescent value. That means the lower membrane potentiality in rotenone alone treated group. But co-exposure of LMWC, this membrane potentiality was increased. Further, acetylcholinesterase and butyrylcholinesterase are the two different cholinesterase enzymes located in the brain that is responsible for the acetylcholine hydrolysis. Cholinesterase inhibitors might improve the cognitive function and reduce the risk of falls in the Parkinson's disease patients. In the present study, cholinesterase activity assay was carried out. As a result, ROT-induced flies showed increase in the activity of acetylcholinesterase and butyrylcholinesterase activation in both head and body of the region of the fly. With co-exposure of LMWC, this activity was reduced. Dopamine is another neurotransmitter produced in the brain of the produced in the part of the brain called substantia nigra. It involves in the memory, mood, and cognitive function. The level of reduced dopamine usually observed in neurodegenerative condition. Hence, the level of dopamine is estimated by HPLC method. As a result, there was a decrease in the dopamine level was observed in rotenone alone treated group. And co-exposure of LMWC, this rotenone induced dopamine level was increased.
Pramod, your time is up.
Yes, madam. At the end, finally, I conclude that rotenone is a neurotoxic chemical which inhibits the mitochondrial complex and increases the reactive oxygen species. And dietary enriched LMWC decrease the oxidative stress and increase the locomotor function in rotenone-induced Drosophila melanogaster. Thank you.
I request Dr. Shalini, can you please evaluate by asking
yes.
questions?
Pramod, it's a very interesting kind of work, and seeing current situation where Parkinson disease in India is increasing, I have few very basic questions. So you have got a very good result. So can a normal human being consume your formulation, which is low molecular weight chitosan, or a person who has got Parkinson disease? So that is my question. So how do you answer that?
Ma'am, the concentration what we have used in the present study, also we have treated to normal flies. There we have got there is no side effects, ma'am.
But can you get a better result, like delay in Parkinson disease or no disease at all? Like for example, consuming nutraceutical functional food, you see that the free radicals are not generated, and it has anti-aging properties. So similar to that, do you also propose any better effect? So if there is no effect, I am not interested in consuming. But if you say that I will become more brainy or more active, so maybe I will consume your product. So did you also observe those kind of observation?
Okay, madam.
Okay, so how much quantity you think that to be consumed to prevent this Parkinson disease in a healthy or in a human being?
Ma'am, this is still in a fly model we have established. Now we are trying with rodent models. Based on that, we can suggest the dosages, madam.
Okay. So what product will you incorporate this? Which product it will go, or it will be like kind of a formulation, powder, or tablet?
As a dietary supplement, we can give, madam.
Okay. Thank you so much, Pramod. All the very best. It's a very nice work. Yeah.
Thank you. Thank you very much, ma'am.
Over to you, sir.
Thank you, Dr. Shalini. I think you whatever you have asked is a valid question for him, where he has to take care of that for his work. And I thank all the presenters behalf of organizing secretary, and I thank the sponsors, Ms. Informa Technologies, for sponsoring this session, and I heartily thank Dr. Shalini Arya for being me to evaluate these all the 5 presenters, where all the presenters presented very well. Really, the whatever the standard is there, it is increasing day by day. We could see. So still, I request all the presenters to work hard and get a better data. And with that note, I think Dr. Shalini, if you have any thing.
Yeah, I would like to, thank you, Dr. Prashant, for wonderfully chairing this session, and thanks to wonderful speakers, because I think if you all would not have participated, would not have presented such an interesting work, this technical session would not have happened. So really, really very thankful. You all have, presented nicely, very good communication skill, very good content of the data, also question and answer session was very interesting. I really enjoyed every second, and you followed all the time, and that is why we were able to finish this on time. So thank you so much, and a big thank you to all the audiences, student members across the country, FST members, faculty, scientists, industry members, who all are watching all of us on YouTube. So thank you to all of you, and thank you to all the organizing committee for giving me an opportunity to chair with Dr. Prashant. So thank you so much.
Thank you, Dr. Shalini. Again, with the thanking the organizers wholeheartedly, and I thank AFSTA for this opportunity.
So I request if all
Yes.
the speakers can open up their camera, and we can take one photo with all of you. So can you all open up the cameras?
For the co-chair's request, I think if everybody opens their camera, I think a few of them already left, I think.
Okay.
Whoever is there, please switch on their camera so that
Yeah. So I will take a photo. Yes, whosoever is available. So thank you so much. Yeah. Thank you, sir. Thank you. Thank you.
Shalini. Okay, thank you. I'll call you. Thank you. I think the IT team can continue with the student activity. That was the request from the AFSTA.
Sorry, sir, can you repeat?
Student activity, which will be in this track, can be continued. That was the request from the AFSTA.
Okay, sir, I'll talk.
Yeah, thank you. Thank you.
Okay, sir.
Please go ahead.
Good afternoon, everybody. Is the video audible? Hello, sir. Is the video audible?
Rectify that and keep that particular image for ready for further. And further, that is the classification, and the classification perform so supervised classification, unsupervised and very important classification of the basic quality of the atom battery, batteries or battery, and then maybe the remaining system different parts. Before it and process. These are the already the technology using the appropriate algorithm. We need to collect and map different things and different factors.
ऑडिओ नाही म्हणतात काय करू?
Hello?
Hello.
We can only see the video, not the audio.
Okay, ma'am. So, ma'am, can you hear audio now?
My topic
Yes, sir.
enzyme active grain
Thank you,
flour.
ma'am.
So starting with the benefits of the grain flour, enzyme activity in the grain flour. So what happens is when we add enzyme activity to the grain flour, it becomes easy for the sugars to be reduced, and then there's better availability of sugars for the yeast. Hence, the application goes mainly into the bakery industry, wherein this is actively used. And then
We can hear the audio.
Found several primary initial applications of lipoxygenase in dows, where based on their ability to bleach the fat soluble carotenoid flour pigments, they have found a way to through co-oxidation, they have found a way to increase the PUFA content. So and then also there have been found evidences of adding enzyme active soybean flour to give better bleaching. And then basically the application goes into the bakery industry. So it has to be increased on an scale so that there's a better use about it in the future. Thank you.
Everyone is stressful, and when we are because of their routine, everyone is stressful. And when I'm talking about nutraceuticals, yesterday when I'm studying about the nutraceutical, only 50% according to the US forecast I have seen. So according from 100%, only 50% nutraceuticals are worked, because all nutraceuticals are cannot work perfectly. So nutraceutical for stress is not right way, according to me. For the stress bursting, we can also go for the exercise, but other supplements like antioxidant we can use, and we can go for ayurvedic treatments also. But nutraceuticals for stress is not a correct way, according to me.
Hello everybody. The video I'm playing are the videos of the students who are undergraduated, the recorded videos.
I am a third year student currently pursuing my BTech from College of Food Technology, VNK, Albany. So the topic assigned for me is non-enzymatic browning. So non-enzymatic browning is obviously the main one of the biggest problem in the storage of a food. So which is occurred due to the which is occur as its name says non-enzymatic, which is not because of the enzymes, but because of the reaction between the proteins and sugars, which is a Maillard reaction. And to prevent this, we have to use and it is basically occurs in the fruits. So and it affect the quality and sensory qualities of the fruits, which is obviously semi-perishable and perishable foods. So we have to overcome this problem with the help of the refrigerations and other post-harvest techniques. So that's with the help of this, we can obviously increase, so by reducing non-enzymatic browning. But non-enzymatic browning is somewhat, for example of the non-enzymatic browning, as of a browning of the potato chips, like when we fried them.
Okay. Is it okay? That's all you want to say?
अभिनव, अभिजीत और मनोहर. Hello.
Yes, ma'am.
Please play the question answers also, na?
Ma'am,
There's nothing wrong with the question answers. You don't have to cut the question answer session also.
ma'am, I've been told not to play.
Question answers, like at least they will know what question or answer has been asked. You are taking so much time in between talks here. You know, the continuity is lost.
Okay, now you made me okay. Uma ma'am. Uma ma'am. Ma'am, can you hear me? Uma ma'am, can you hear me?
Yes, Manohar.
Ma'am, it was discussed earlier that only the presentation part should be shown, not the question answer. That is only for the internal discussion.
Doesn't matter, but even that is also not coming continuous.
And that they should tell them. Abhijit?
Tell them.
Abhijit?
Yes.
Why is it not continuous, coming continuously, it seems?
It's in the cutted part. The every video is different, so I'll playing it differently.
Okay, whatever it is, at least from the start to the end of the presentation, it should be clear, no?
Okay.
That
I'll make the flow.
It should be 0, man.
Yes.
You should not have gaps, these big gaps.
Sorry for the interruption, ma'am. I'll make the gaps. I will make no gaps.
Don't make gaps. Okay, thank you.
Yes, ma'am.
Where
Sorry
can I
for
see
the
it?
inconvenience.
Where are you hosting it, Abhijit? It is here directly, or where should I see that videos? Now will you host it now?
Yes.
While food packaging, we give the nutritional labeling to any product, any food product. That is a nutritional labeling. The nutrition contain in any product, that is a nutritional labeling. And every product should need this nutritional labeling for consumer purpose and other nutrients that is contained in a product. This nutritional labeling is important, very important to any product. For any product, and this labeling should present in any packaging of product, of food product. The companies, the packaging companies should label any product, any food product, that is labeling should label any products.
Anything else you want to tell, Shinde? That's all.
That's all, sir.
And now, his area of expertise, but not limited to the logical characterization of
Abhijit?
Yes, I'm playing the video.
Abhijit, I
Yes.
hear some external noise from your side actually. Any other video is or something is being played in your browser?
No, actually the session is on another desktop. So
No.
you might be hearing that.
You cannot, it's an external noise. If you are playing this thing, it should not come as a video if you are playing. If you are just presenting and video, how does the audio microphone, just mute the microphone when the video is being played.
Okay.
Abhijit, is there any issue in presentation?
Abhijit. 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 Manohar.
Madam,
tell him to run.
There is some network issue or some technical issue from their side.
RS here. That's enough. This is looking so poor.
I am from College of Food Technology, Vasantaraw Naik, Marathwada Krishi Vidyapith, Parbhani. Can I have topic is polysaccharide, polyunsaturated fatty acid. Polyunsaturated fatty acid are fatty acids that contain more than one double bond in their backbone. The class includes many important compounds such as initial fatty acids and those that gives drying oils their characteristic properties. Food source of polyunsaturated fatty fats includes walnuts, sunflower seeds, flax seeds or flax oil, fish such as salmon and throughout, corn oil, soybean oil, and sunflower oil. Structure of polyunsaturated fatty acid are hydrocarbon chain containing two or more double bonds. Their characterization of BUFAS as either an N3 PUFA and N6 PUFA refers to the position of the first double bond relative to the methyl end of the fatty acid. In nature, double bonds are usually in the cis format. Two types of polyunsaturated fat are omega-3 and omega-6 fatty acid. For omega-3 fatty acids are found the food from plants like soybean oil, canola oil, walnuts, and flax seeds. Omega-6 fatty acids are mostly in liquid vegetable oil like soybean oil, corn oil, and safflower oil. Functions of polyunsaturated fatty acids are a type of fat in certain foods. Polysaturated fatty acids, PUFA, are important for nerve functions, blood clotting, brain health, and muscle strength. They are essential, meaning that the body needs them to function but cannot make them. So a person must get polyunsaturated fatty acids from their diets. What are polysaturated fatty acids? Polysaturated fatty fats.
Time is over.
Antioxidant properties based on their chemical structure. They are classified as flavonoids and non-flavonoids. Flavonoids form largest group over 9,000 compounds. They are found in food such as tea, wine, chocolates, fruits, vegetables, and extra virgin olive oil. Polyphenols are now widely considered to play an important role in maintaining health and well-being throughout the body, mainly as a result of their antioxidant activity.
साक्षी, एक डाउट है, आप पढ़ तो नहीं रहे हो, आप अपने लफ्जों में बोल रहे हो, तो गूगल देख के पढ़ना मना है, डिस्क्वालीफाई हो जाएंगे आप, गूगल देख के मत।
या बोलिए बोलिए, और कुछ बोलना है आपको?
नो सर।
अच्छा, ओके, हम आपसे एक दो सवाल पूछेंगे, आप जवाब देंगी?
That good manufacture GM means good manufacturing practices, and it is very important to in our food sector. In our FSSAI, conducting various types of good manufacturing practices such as
Santoshi, did you understand the topic? Because I told you GM foods.
Genetically modified.
Genetically modified foods, not good manufacturing practices. You are talking about GMP. I asked you GM foods.
GMO.
Yeah. So,
और 2 मिनट दे देंगे आप GMO पे बात करना, genetically modified food.
Okay, sir. Sir, genetic.
Yeah, please tell me.
Genetically manufacturing means
you can start now.
it is genetics are major role in their manufacturing practices. That good manufacture GM means good manufacturing practice. Any other microbiology is a major role in genetic manufacturing.
Okay.
Sir,
That's all, huh?
Yes, sir.
Okay.
Thank you, sir.
You want to ask some question?
Okay, sir.
It is functional foods, okay? Not
Yes.
function of foods.
Functional food are, sir, those ingredients which give value more than the nutrients.
Okay.
Speak for 3 minutes.
3 minutes presentation is there, so you have to speak for something more.
Sir, I can't recall all these things.
Okay. But anything you want to tell before we close the session?
Functional food, sir.
Okay, why they are called as functional foods?
Yes, sir.
Why they are known as functional foods?
Functional foods, because, sir, they give more value than the nutrients.
Living organisms, sir, or microbes. Sorry, probiotics are living microbes, and That can be.
Tejaswini,
Yes,
you
sir.
can look towards us when you speak, not towards your screen. Yeah.
Don't read.
Yes,
Look
sir.
at us and speak.
Yeah. Okay. Yeah.
Don't
Now you
read.
speak.
Probiotics are live microbes, sir. And that can be formulated in different types of products, including food, drugs, and dietary supplement. And sorry, sir.
No problem.
And that is very beneficial effects for the human and animals. Any sorry, sir, I can tell this much.
Dietary fiber, also known as roughage, is the indigestible part of the plant foods. Fiber has a host of health benefits, including reducing the risk about the heart disease and like diabetes, sugar patients. Okay, fiber is mostly in vegetable, fruits, and whole grains, legumes. It's found in these. There are two types of fibers: insoluble and soluble fibers, and both play an important role in our health, daily life. Insoluble fiber does not dissolve in water and adds a bulk to the stool, preventing constipations. Soluble fiber absorbs water, forming a gel-like substance in the digestive
Sir,
system.
हमें देख के बोलना please.
क्या मैम?
हमारे तरफ देख के बोलना. Look at us and speak, not the screen.
Hello ma'am, am I audible?
हमें सुनाई दे रहा है. आप हमारे आप screen से पढ़ो मत.
Speech, okay ma'am. Soluble fibers absorbs water, forming a gel-like substance in the digestive system. Soluble fiber may help lower cholesterol levels and help regulate blood sugar levels. Benefits of eating fiber. Dietary fiber is an essential part of a healthful diet. It is crucial for keeping the gut healthy and reducing the risk of chronic health diseases like heart diseases. Most people in the US do not get enough fiber from their diets. According to some estimates, only 5% of the population meet the adequate intake recommendations. This means that most people in the US could get health benefits. Protection against heart disease. Several studies over the past several decades have examined dietary fiber effect on heart health, including preventing cardiovascular disease and reducing blood pressure. And it also reduces the cholesterol level. And the author says fiber is important for keeping the gut healthy. Eating enough fiber can prevent or relieve constipation, helping ways to move smoothly through the body. It also increases healthy gut microbiota. Thank you.
Okay. चल आपका टाइम हो गया है. अब आप क्लोज कर दीजिए. मैं आपको क्वेश्चन पूछता हूँ 2-3.
Hello ma'am, hello everybody. The video part is over, so I'm going to play the presentation part now.
Okay.
Good afternoon, everyone. This is Amrita Ray, a PhD scholar in CSIR CFTRI. My topic is food fortification, its approaches and limitations. Food fortification is defined as a process where vitamins or minerals are usually added to a food to develop its overall nutritional quality towards improvement. And the nutrients that are being added to this food are not necessarily will be present in the food before the processing. Now the question is, why is it required? In short, I can say to combat malnutrition caused by the deficiencies of these micronutrients. Micronutrient deficiency is among one of the major reasons for poor health and mental development in our country. There could be different kinds, say reduced brain growth, work performance, weak immune system, or maternal or child death. The scenario is pretty scary. I can say almost 40% of the world's malnourished population live in our country, and about 40% of pregnant women worldwide are anemic. Also, 4 out of 10 children in India are not meeting their full potential because of chronic undernutrition. Now, there are approaches to combat malnutrition, food fortification being one of the major components, also with food diversification and supplementation. Food diversification requires ensuring a balanced diet and a wider selection of food from different food groups. But the limitation here is the lack of access to good food and also their appropriate dietary habits. And for food supplementation, to administer capsule or tablets, which could be expensive, which makes it a short-term approach. Also, there could be personal inhibition to pop a medicine on a regular basis. All these things could be overcome with the food fortification approach. This does not require the target groups to change their food consumption pattern. Also, it can be incorporated in the existing food production and distribution system, making sure that the delivery to a large population can be done at the same time. And this can be considered as a practical and a long-term approach, being a cost-effective thing. There are different technological approaches for food fortification. I can say flour and grain fortification, liquid food fortification, encapsulation, biofortification, and also food-to-food fortification. We'll start with the flour fortification. Grain flours are staple food for most of the population across the globe. In India, around 50 to 55 MMT atta is being produced annually, and some 20 MMT maida. If we can fortify these staple food, we can reach a large population, and this population would be consuming this fortified staple without any other difficulties. In industry, usually a micronutrient feeder is utilized for food fortification. This is a diagrammatic representation of the food fortification system for flour in continuous and batch process. It is taken up in the industries where we can see in the continuous process, the micronutrients are added to the flour streams and they are mixed in the conveyor before being packed. And in the batch process, it can be utilized in mill as well as small scale industries. The process is very versatile and it can be utilized for atta, maida, besan, or any other ground flour. Further, we can go to grain fortification, where the grain is powdered and mixed with the premix. Further, a dough is made and extruded to make a grain which is similar to the size and shape of the original grain. Now, these are called fortified kernels. These fortified kernels are further blended with the non-fortified, unfortified grains and made in a batch and continuous process to reach final fortified grains. So there are batch and continuous process for these fortification also. The photographs are from FSSAI I have taken. The next could be liquid fortification. This is relatively a easier and simpler process. Milk and oil are usually fortified in our country, where chilled milk is blended with the premix, and that premix is further pasteurized and packed and sold as fortified milk. In case of oil, a part of the oil is mixed with the fortificants like vitamin A and D in the blending chamber, and further this particular part of the oil is actually added to the complete amount of the oil and blended together to make the fortified oil. Further, I can talk about encapsulation, which is a process where the micronutrients are coated with an edible coating material, which acts as a physical barrier between the food matrix and the micronutrient. It protects the micronutrient to interact with the food matrices, and also protects it from the oxidation, in extending its shelf life, I can say. The good food encapsulation would be the lipid-based material coating, which are relatively expensive than the normal uncoated materials, but this enhances the bioavailability of the nutrients, as the lipid outer material will be dissolved only once you have ingested it inside your gut. The lipase will degrade it, or while already we have put the encapsulated material in a product, say during baking, it would only melt and release the micronutrients. This encapsulated ferrous sulfate and fumarate are usually used for cereal flours or infant formulas. Further, we can talk about biofortification of food, wherein plant breeding, agronomic practices, and also genetic modification are being explored. In case of agronomic practices, there are application of nutrient-rich fertilizers for these plants, so that the plants will take up these micronutrients and the tissues will be rich in micronutrients. For genetic modification, the modification in the existing genetic traits are being explored, so that the micronutrient development is improved. The iron and zinc biofortification of cereals can be considered as a solution to overcome the malnutrition of these particular components. Next comes food to food fortification, where one component is usually added to another usually locally available otherwise wholesome food. And one important point of this fortification is that the fortificant food should not affect the quality parameters of the food being fortified. The classic example of this could be multigrain atta. Now, there are different types of food fortification: large scale, small scale, or even point of use. When it comes to large scale fortification, the general population is usually addressed. For example, when we fortify the staple food, it can reach a mass. Targeted fortification, which could be for a specific population, for example, a fortified snack for children. And there is market driven fortification, which is definitely a business initiative for commercial products, but it could be large or small scale. For example, during this COVID situation, we might appreciate vitamin C or zinc enriched product. And the last comes as point of use fortification, which is usually practiced at home for cooked food. Now, as any other good things, limitation of food fortifications are also there. The ones I can enlist are the government policies in developing countries of food fortifications are not always very robust. And also there might be lacking in the centralized food processing unit at a large scale or affordable technologies. And at times, socioeconomic conditions limit the affordability of the processed food. So there are a few key points I would want to mention, like cost of equipment or premix, the monitoring of the whole system, the quality control standards during the process, or the distribution systems. These are the micronutrients for fortification in India that are usually utilized. India promotes fortification, and FSSAI has laid the specifications. When it comes to flour and rice fortification, if we want to call it as a fortified flour or rice, we must add iron, folic acid, or vitamin B12. When it comes to milk and oil, vitamin A and D are used, and iodized salt has been in use for ages. To conclude on my presentation, I can say that malnutrition, or the hidden hunger, has its spread across the globe. Fortification is proven to be safe, sustainable, cost-effective, and a long-term approach to eradicate malnutrition. It can be incorporated in the existing food distribution system to reach a larger population, and has been proven to be beneficial for health and economy of the country. Now, few limitations like availability of affordable technology or streamlining of the monitoring of the large-scale process could be addressed by government interventions. So my take-home message would be, as the great famous Hippocrates has mentioned, let food be thy medicine and let medicine be thy food. Food fortification could serve as a potential approach for improving health status of the country, in turn positively influencing the country's growth and development. Thank you.
Okay, sir. So good. Okay, sir. Good afternoon to all the respected dignitaries and dear students. Myself, Ansi Thomas, PhD scholar in the Department of Fish Processing Technology, ICFoST. And let me thank the organizing committee for giving me such an opportunity. And today, what I am discussing about the application of cold plasma as a non-thermal techniques in fishery products. Next slide. So, these are the topics I am covering in this section. Introduction to cold plasma, devices used for the plasma generation, plasma activated water, and application of cold plasma in packaging as well as in seafood products, and its limitations and future prospects. Next slide. So next slide. Okay. So as an introduction, introduction. So among the food, fish is considered to be most nutritious and healthiest food because it contains high amount of proteins, vitamins, minerals, and in case of fatty fishes, it contains high amount of polyunsaturated fatty acids, and it cannot be synthesized in human body, so it must be added through diet. So fish is considered as most nutritious, and according to the status of FAO, we can find that the per capita food fish consumption rose from 9 kg to 20.5 kg in 2018. So this implies a 1.5% growth in each year. So it means the consumers' demand towards the fishery products was increasing. And seafood is highly nutritious. At the same time, it is highly perishable. And the quality degradation is mainly happens because of the microbial deterioration and also the chemical degradation. So the safety of the seafood becoming a global threat nowadays. And because most of the seafoods are consumed as raw form, and the major pathogens associated with the seafood includes Listeria monocytogenes, Salmonella, Vibrio cholera, Staphylococcus, etc. And it will cause illness to the health of the consumer, and in severe condition, it will cause the death of the consumers. And recently, the China reported COVID-19 from the frozen white shrimp from the Ecuador, and which was found to be in the packaging material and also the container of the product. Next slide. Okay, so the increasing demand of the consumers towards the health and safety of the food was increasing. So we have to consume healthy food in order to keep us healthy. So let food be your medicine. And next slide. So in order to reduce the microbial contamination, we can opt for thermal processing methods. There are two types of thermal processing methods generally employed, that includes pasteurization and sterilization. And in case of pasteurization, we are employing low temperature treatment. Sterilization is opting for high temperature treatment. Even though these treatments are responsible for the reduction in microbial load, it has some limitations. It may sometimes cause nutritional loss, and also in such cases, certain cases, it may cause the overheating of the product. And I already told consumers mostly prefer seafood as raw. So in such cases, we can't opt for the thermal processing method. So in order to overcome every drawback or all these things, we are exploring more onto the non-thermal processing methods. Next slide. And the major non-thermal processing techniques include pulsed electric field, high hygrostatic pressure, ultrasound, pulsed light, cold plasma. And all these technologies can utilize for the reduction in microbial load without the application of heat. So it will create an equilibrium between the safety and minimally processed foods. And here in this slide presentation, I am discussing with the cold plasma. Next slide. And cold plasma is a neutral ionized gaseous form that is made up of ions, free electrons, gaseous atoms, and molecules, as well as the UV photons. And it is formed when the gas is injected into an electric field generated by the two electrodes. And the most commonly utilized gases for the plasma generation includes air, oxygen, nitrogen, carbon dioxide, and noble gases. Next slide. So plasma can be produced by a variety of energy sources. It includes, we can use radioactive energy, electrical energy, electromagnetic radiations, optical energy, and thermal energy for the production of plasma. Carrier is generated, and this charged carrier can colloid with the molecules and neutral atoms in the gas, resulting in the generation of electrons and ions. And CP also generates several species of such as reactive oxygen species and reactive nitrogen species, which is actually responsible for the antimicrobial property. Next slide. So the advantages associated with the cold plasma includes high microbial inactivation, and it can be suitable for treating sensitive foods, and less power input is required for the utilization of cold plasma. And we can also avoid the risk associated with the thermal and chemical treatments. Next slide. So we can generate cold plasma in 3 ways by using the dielectric barrier discharges, plasma jet, in 4 ways. Dielectric barrier discharges, plasma jet, corona discharge, and gliding arc discharge. Among these, next slide. Among this, dielectric barrier discharge and the jet plasma are most commonly used. And in dielectric barrier discharge, and insulating substances such as glass, quartz, ceramic enamel, mica, such materials are used, and it will used to cover one of the electrodes. And this will act as a stabilizing material and produce a large number of micro discharges for the uniform treatments. Next slide. And we can also apply plasma for the sterilization of the water. And we are mainly using water for the processing purposes, and the high amount of water is also generated as a result of processing discards as effluent water. So we can treat both the water with plasma in order to sterilize the water. So we can ensure less microbial load in the processing potable water, and also at the same time in the effluent water. Next slide. We can another application of cold plasma in food is the food packaging. So by the application of the cold plasma, we can improve the barrier qualities and also the mechanical properties, like it can improve the printability, sealability, and mechanical resistance of the packaging material. Next slide. And when we are coming to the application of cold plasma in seafood, next slide. So when we are harvesting the product, raw material to the final product, there are several steps, like we have to wash, process, and pack the final product according to the consumer demand. So in the all process, we can utilize plasma at different stages. So for the washing purpose, we can use plasma activated water, and it will help to decontaminate the raw material. And we can also treat the wastewater generated with the plasma, so we can reuse the water again. And the another method for the processing and packing also, we can use the plasma, so we can improve a good quality product without less microbial load. Next slide. So these are also another examples of the cold plasma applications that are studied. So all these studies shows that there were a significant reduction in the microbial quality when they are treating it with plasma, but it also showed some amount of lipid oxidation as a result of the application of the plasma, and also some textural qualities or color changes or the physical property alteration may happen. Next slide. Next slide. So even though the plasma is considered to be high in antimicrobial properties, it may sometimes cause some other impacts onto the fish products. So it includes the lipid oxidation, protein denaturation, physiochemical changes, and sensory changes. All these properties can be adjusted by using the altering the treatment parameters. Next slide. So when we are considering the limitations, the major limitation was it can be used for uniform sized products only. And CP can result in undesirable textural and discoloration, quality changes, discoloration, etc. And it will also promote or enhance the lipid oxidation. And sometimes in some cases, it may retain the residues after the processing. And high cost of installation also was a major disadvantage when we are considering the plasma. Next slide. Even though along with this constraint, we can conclude that plasma is a promising non-thermal technology. We can utilize the plasma as increased or higher way by incorporating such things, because the major disadvantage with the plasma application is the lipid oxidation. So we can utilize the antioxidants, either it is of synthetic or natural origin. We can treat the product before the application of plasma, so we can improve the shelf life of the product, we can reduce the level of lipid oxidation. And several studies also shows that adjustment of the process parameter will also improve the textural quality of the product. So it can be used as a good alternative for the thermal technology than the thermal technology. So next slide. These all are the references I got, and that's all about my presentation.
Good afternoon, everyone. Myself, Ashan Kumari from Amity University, Uttar Pradesh, Noida campus. And currently I am working as a project assistant and also pursuing my PhD from food technology. My today presentation topic is fortification of food using fish byproduct, protein and omega-3 fatty acid to improve human health. 2 million population of the world are suffering from the malnutrition due to the deficiency of different micronutrients, which affect the economical, mental, and physical health of the human. In India, malnutrition is a very serious problem, which is very serious problem due to the deficiency of different vitamins, iodine, iron, folic acid, which leads to the different disease like night blindness, goiter, anemia, or various birth defect. In India, prevalence of anemia is very high due to the deficiency of iron. The anemia is mainly highly affect the children of age group of 6 to 59 months, followed by the women up to 15 to 49 years. And anemia is also affected by on the basis of the income group of the population, it's prevalence in both the income group, but is a highly prevalence in poor income group population. Prevalence of nutrient tube defect in India is high in India due to the deficiency of folic acid. Fortification can be one of the potential approach to combat the different type of malnutrition. If we can define the fortification is a process of adding micronutrient to the regularly consumed food during the processing to enhance their nutritional value is known as food fortification. It is a safe and cost-effective intervention, such as addition of vitamins and minerals in food product like milk, wheat, flour, rice, oil, etc. Some of the commercially available fortified community and its health benefits are milk and oil fortified with vitamin A and D help to fight against the night blindness and also help to strengthen the bone. When wheat flour and rice fortified with iron, vitamin B12, and folic acid, it's helped to fight against the anemia, malnutrition due to different vitamins, and it also helped to fight against the NTD. And salt fortification with iron and iodine help to fight against the anemia and also help in normal growth of thyroid gland and also improve the brain function. Different approach of food fortifications depends on the number of factors such as type of malnutrition, age group, type of dietary composition, food and food processing infrastructure, production capacity, and on the basis of government regulations also. Different approaches are large-scale food fortification, biofortification, point of use, and home fortification. In large-scale fortification, micronutrients are added to the commonly consumed food such as salt, flour, oil, sugar, and other commodity during the processing in industry itself. For example, the fortification of wheat with folic acid, oil with the vitamin A, milk with vitamin A and D. Biofortification, it is a technique of growing the food crop to boost their nutritional content by the help of genetic engineering, agronomic approach, or by plant breeding. Some example of biofortification are rice biofortification with iron and zinc, bean biofortification with iron and zinc, maize, sweet potatoes, fortification with iron and vitamin A, etc. Point of use and home biofortifications are the addition of vitamin and mineral to the cook or ready to cook food before consuming is called point of use fortification. In 2016, WHO has started the biofortification point of use biofortification in different school and refugee camp by using micronutrients powders. These are some of the government supported program for fortification of food, such as integrated child development service, in which supplementary cooked food are given to the childs. Fortified foods are given during the midday meals in school. Fortified foods are ready to eat foods are fortified with different micronutrients and targeted public distribution service. The benefit of food fortifications are it improves the health of large section of population. At a time, it is a safe method, it is a cost-effective intervention, and it does not alter the characteristics of food like taste, aroma, texture of food. Disadvantage of food fortification are it decreases the shelf life of food. Regular quality check is needed. If we cook the fortified food for a long time, its nutrient content may be lost. And for in the similar way, the protein deficiency is also very common in India. Approximately 70 to 80% of the population are suffering from protein deficiency. For example, the 70 to 80% of the women and household wives are protein deficient. Approximately 62% of pregnant women and lactating mother facing the problem of protein deficiency. 44% of child of age group 15 to 50% are suffering from protein deficiency. So it is very important to find the new alternative for the protein source in order to minimize the protein deficiency in the country. fish byproduct can be very potential source for the protein and omega-3 fatty acid. In India, since India is one of the world top fish producer, and the growing need of world for fish has increased the demand of processed seafood, which generate around 100 million metric tons of byproduct worldwide, and in India it's alone produce 4 million metric tons of byproduct. This byproduct not only poses a serious environmental threat, but also the potential source of protein, collagen, gelatin, and omega-3 fatty acid. So, by help of suitable and feasible technology such as enzymatic hydrolysis, chemical microwave-induced hydrolysis, and microbial fermentation, we can extract the valuable component from these byproducts, and we can use this valuable component for the fortification of different food. In conclusion, I will say that the food fortification is a low-cost technique that has a potential to reduce the malnutrition all over the world. Food fortification study have shown the significant and positive effect on the management and elimination of malnutrition among the vulnerable community, especially women and the children. The value-added compound extracted from the fish industry byproduct can be used for the fortification of regularly consumed food, which help to fight against the protein deficiency in the country. Thank you.
Next, I will change the slide here for you. Okay.
Okay, sir. Okay, sir. Good evening, everyone. I have taken the theme of food fortification approaches and limitation. I am from CSR CFTRI, Mysuru. Sir, next. Sir, next. Sir, before one, sir. Sir, before going to food fortification, sir, first we know about little nutrition. According to WHO states that the science of food and its relationship to health, is concerned primarily with part played by nutrients in body growth, development, and maintenance. Next, sir. Nutrients are organic and inorganic complexes contained in food. Mainly, nutrients are divided into macronutrients and micronutrients. Macronutrients are called as protein, fats, and carbohydrates, which are often called proximate principles because they form the main bulk of food. And micronutrients, they are vitamins and minerals. It's required in small amount, which may vary from a fraction of a milligram to several grams. Next, sir. Key of micronutrients like iodine, iron, vitamin A, folic acid, zinc, vitamin D, calcium, and other micronutrients like vitamin B2, B6, and B12. Next, sir. Micronutrient deficiencies in India. Micronutrient deficiencies such as iron deficiency, anemia, vitamin A deficiency, iodine deficiency disorders. These are the continue to be significant public health problems throughout the India. Next, sir. Like iron, iodine, and vitamin A deficiencies are high risk in the world. Like emerging evidences, it is developed recently, reported on plasma levels of zinc, folic acid, and vitamin D. And sporadic deficiencies means like it is irregularly happened or infrequently related to vitamin B12, B1, and B2. These are the evidence of increasing fracture risk of Indian population attributed to calcium and vitamin D deficiency has also been reported in the recent past. Next, sir. Coming to food fortification, According to WHO, the process whereby nutrients are added to foods in relatively small quantities to maintain or improve the quality of the diet of a group, a community, or a population. Next, sir. The main reason for the malnutrition is poverty and economic crisis, impact on the nutritional security of the consumer, food prices goes up and nutritional value goes down. As people eliminate higher priced items such as proteins, fruits and vegetables from their diet to stretch their food budget, they can still get essential vitamins and minerals if their food staples are fortified according to internationally agreed standard. Next, sir. History of food fortification. This food fortification is not the new technique. It is the old technique they used in World War II itself, used by United States. Iodized salt was used in United States, and niacin has been added to bread in the USA since 1938. And vitamin D was added to margarine in Denmark in early 50. And vitamin A and D were added to Vanaspati hydrogenated vegetable oil in India since 1954 as per mandate. And folic acid was added to bread for preventing neural tube defects in infants in the 60s. And over the last 3 decades, fortification of foods has become a public health measure for preventing deficiencies of vitamin A, iron, folic acid, and iodine. Next, sir. Need for regulation for micronutrients, fortification of staple foods. Like what is fortification means is the addition of one or more essential nutrients to a food, whether or not normally contained in food, for the purpose of preventing or correcting a demonstrated deficiency of one or more nutrient in the population or specific population groups. Next, sir. Fortification program around world, like more than 80 countries are fortified with the products like micronutrients. Like Egypt, they can fortify with the iron and folic acid with bread. Coming to India, they are fortifying salt with iodine and iron, oil with vitamin A and D, and atta with folic acid and iron, and juices with vitamin C, D, and calcium. Next, sir. These are the open market availability. These are already commercially available in market, like wheat fortified with wheat flour is fortified with iron and zinc by the General Mills, ITC Patanjali, and rice with LT Foods, and salt with Tata Salt. Next, sir. And edible oil, AAK, Kamani Kargil Company, and milk, Mother Dairy, and Varka. Next, sir. Fortification of food under the government supported programs like fortification of integrated child development services, supplementary cooked food, and fortification of food for the midday meal. Next, sir. Fortification of wheat flour supplied through targeted public distribution system, TPDS. Fortification of factory produced ready to eat, RTE foods. Next, sir. However, for the packaged foods available in the open market, there are no clear guidelines on nutrients that can be fortified or permissible under law under the Prevention of Food Adulteration Act and the Food Safety and Standards Act. Voluntarily, fortification guidelines are only given for whole wheat flour and the refined wheat flour. Next, sir. Vehicles for fortification with combinations of micronutrients. Vehicles means the commonly eaten food fortified with the fortification we call as vehicles. Wheat and rice are fortified with the iron, folic acid, vitamin B12 and zinc. It tackles anemia, boost immunity. These wheat and rice we can use in Anganwadi centers and school midday meals programs. It can reach up to 84 million children. And oils we can fortified with the vitamin A and vitamin D. It builds immunity and bone health, easy to add, and it can reach 98% of the Indians population. Next, sir. And salt is fortified with iron and iodine. It tackles anemia and iodine deficiency like goiter and can be used in all meals and sold in open market. It can reach potential up to 150 million. And milk it is fortified with vitamin A and vitamin D. It builds immunity and bone health. It is a low cost and its potential can reach most of the India's urban population. Next, sir. These are the criteria for fortification. Nutrient deficiency should be widespread. The vehicle food must be consumed by the target group. The high consumption of fortified food will not lead to toxicity, and addition of micronutrients should not change the taste, color, flavor, texture, and shelf life of the food item. The item of food should be centrally controlled and monitored. The cost of fortification should be affordable. Next, sir. Approaches for arriving at fortification levels. National RDA of nutrients we required, and prevalence of deficiency in the region, per capita consumption of food vehicle to be fortified, current dietary habits of the population, stability of the nutrient in the food being fortified, and chemical sources. Next, sir. Advantages like providing certain nutrients simultaneously in the same food improves the utilization of certain vitamins and minerals. For example, vitamin C absorbs the iron, providing nutrients through the regular food supply and distribution system reduces costs. It is socially acceptable, fast and broad, and organoleptic properties. For food fortification is the safety strategy and cost-effective approach also. And marketing and distribution system is very easy and readily visible. In addition, fortification will reach secondly target risk groups such as the elderly, the all, and those who have an unbalanced diet. Next, sir. Disadvantages of food fortification is shelf-life of fortified milk cereals is reduced. Regular quality control is essential, and prolonged cooking of fortified food leads to 90% loss of vitamin C, and fortified commodity is more expensive. Next, sir. Coming to limitations, a thorough knowledge of dietary habits and nutrients intake in the target groups and complementary educational program is required, particularly when the fortification influences organoleptic characteristics of the food, and food fortification is not the ultimate solution of the nutritional deficiency. Next, sir. Future challenge of food fortification, create community awareness about benefits of food fortification. Private sector, governments, and international agencies need to make commitments for investing in food fortification. Increase availability of fortified foods to the vulnerable groups of population. Government and international agencies should encourage fortification by way of tax, concession, or duty rebates. Regulatory authorities to recommend uniform food fortification guidelines to the group countries and develop technologies that will produce the futuristic food. Next, sir. Food adulteration. It related to food fortification. Common people will confused with food adulteration and food fortification. Food adulteration means the process of lowering the nutritive value of food either by removing a vital component or by adding substances of inferior quality is called food adulteration. Next, sir. Some of the common food adulterants, health hazards of adulteration. Coming to health hazards, toxicity due to toxic sweeteners, additives, colors, etc. Then epidemic dropsy due to consumption of argemone oil mixed with mustard oil. Next, sir. Disadvantages for the consumer. Consumer is paying more money for foodstuff of lower quality. Some forms of adulteration are injurious to health, even resulting in death. Next, sir. Coming to conclusion, fortification offers sustainable solutions to the escalating micronutrients related malnutrition problem. Fortification is one of the most effective, simple, and an inexpensive strategy for alleviating the existing deficiency. Next, sir. Thank you. One and all.
Okay, so good afternoon, all the jury members and respected sir. So I'm Manasvi Sharma and I'm from Mount Carmel College. Currently, I'm doing my master's in food science and nutrition. So today I'll be presenting my PowerPoint presentation on the topic nanotechnology, principle and applications in food science. So before that, I would like to give you a brief introduction about it. So we all know that food products are rich in moisture and they are loaded with high nutritional content. So they are an easy target for microbes to grow. And because of that, since they grow on the food products, they make it unfit for the consumption for humans. And since food is the main source of energy, food safety is one of the key concerns that one should be focusing on when it comes to advancements in technologies and utilization of them. So food and nutrition is the need of the hour that one should be focusing on. We all know that food quality and safety requires real-time monitoring at critical processing points. So fast and precise analytical methods can be used in detection of microorganisms, and they can help in terms of food safety. So I would like to tell what is nanotechnology. So nanotechnology basically refers to the manipulation of atoms and molecules at nanoscale level. So where the dimensions are 1 to 100 nanometer. They enable in controlling the nanoparticles in order to create new products or technologies. So they serve main purpose in industrial, medicinal, and energy purposes sector. So in food science and nutrition, they have turned out to be one of the most promising technology. How they have turned out to be that, we'll learn in the coming slides. So now moving forward, these are few applications of nanotechnologies where the nanotechnology has helped a lot. For example, nanosensors, they have been helping in detection of microorganisms. Then there are nanofoods, using the nanotechnology by incorporating them in food products. These have helped in enhancing the nutritional profile of the foods and enhancing the flavor as well. Then comes nanoencapsulation. Nanoencapsulation has also helped a lot in terms of food sector by encapsulating few of the vitamins or minerals or in overall nutrients in the form of pills. Then nano coating by using the nano emulsions and other applications. We'll learn about them in the coming slides. Okay, so first about the nanosensors. So nanosensors, as I told, that they help in early detection of microorganisms that are present in the food. So although there are many conventional methods that can be used in detection of microorganisms, nanosensors have proved to be more stable and easy to use. Since in case of pathogens, nanosensors, they take less time and they are culture dependent or also require low cost. But when it comes to conventional method, they require more time as they require incubation period for 5 to 7 days. Because of that, they might go through contamination as well. The samples get contaminated easily. But in terms of nanosensor, when we talk about nanosensors, they are more easy to use and they are very stable and they are highly precise. So now moving forward, what is the mechanism of this nanosensor? How do they work? So they require analyte, bioreceptors, transducer, and output. I would like to show this with the help of a diagram. Yeah, this is the diagram. So what really happens when it comes to nanosensors is, and so basically analyte is present. They are very specific for an analyte. These can be organic or inorganic particles. So they need bioreceptors so that analyte can lash onto them. And these bioreceptors are covered with the nanoparticles. These can be metallic, magnetic, quantum graphene oxide, carbon nanotubes, etc. When they once lash onto it, they use the transducers. The transducers are basically the devices that convert non-electrical quantity to electrical one. So they can be electrochemical, optical, and mechanical. So in electrochemical, they use amperometric, voltammetric, potentiometric transducers, while in optical, they use colorimetric and fluorescence. So how do they work? Like in terms of when we talk about electrochemical nanosensors, so basically an electrode is the key component when in electrochemical nanosensor. So they are employed as the solid support, which helps in immobilization of biomolecules. So basically what it does is it prevents the movement of biomolecules and electron movement. So the biological recognition elements such as enzymes, proteins, antibodies, these are used in the biochemical section. So moving back to this diagram, so these the bioreceptors, like I told, enzymes, antibodies, oligonucleotides, these are used. And here, like this green thing is shown, it acts as a electrode in electrochemical nanosensor. So these are they require low cost, they are highly accurate, and have the ability to detect the changes directly based on between the sensor and the sample. Now, this is one of the example of electrochemical nanosensor, like detection of Salmonella typhimurium detection in apple juice using potentiometric nanosensor, and detection of S. typhimurium in milk sample by using ion selective electrodes. Detection based on immunoassay sandwich format. So basically, as you can see in the diagram, as you can see in the diagram, that without bacteria, the electric current is like this. But when bacteria is captured, the electric current is loaded, and it forms a sandwich kind of a format. These are a few examples that I went through in one of the research articles. So here you can see the target analytes. There are different analytes that are visible, like sulfide, nitrite, azodize, melamine. And these are the transducers, volumetric and conductometric, impimetric. Then recognition elements, the elements that have been used differently, like selective oxidation is there, then DNA, then antibodies, and the type of nanomaterials that have been used along with the food matrix. Like if we talk about the copper one, first one. So the transducer uses voltammetric, and the recognition element is selective metal complexation, and nanomaterials used are silica and NPs. And the food matrix in which they are used is fish, shrimp, rice, and tobacco. Similarly, like that, different target analytes have been used. Now, this is one of the conventional methods, like I told, that conventional methods have been used in pathogen detection. So they help in detecting the foodborne bacteria by culturing methods, basically by sample preparation, isolation, enrichment, so that we can see different colonies by characterization based on their morphology, biochemicals, phenotypes. So they help in that. But since they take more time, so nanosensors are better in detection than these conventional methods. Now, talking about the calorimetric nanosensor and fluorometric nanosensors, these are the type of nanosensors that come under the category of optical nanosensors, which use the light, basically. So now talking about the calorimetric nanosensors, they help in detection of microorganism in the presence of through color change. So we can observe that there is a color change with the naked eyes. One of the example of this is using AUNPs. AUNPs are basically the gold nanoparticles. So, and antibodies to detect Salmonella, Listeria, and E. coli in 10 minutes. So you can see the shift. You can see the change basically in the time duration. When we do it in conventional method, it takes 5 to 7 days. But with the help of calorimetric nanosensor, it took only 10 minutes. So, and another example is that detection of Streptococcus or Legionella pneumophila in 15 minutes. And when talking about fluorometric nanosensor, you making use of fluorescence. Fluorescence is basically the illumination that comes, is associated when backgrounds become low, basically dark, and observing fluorescence can help in discriminating rather than small color changes. So they can be applied in detection of cyanide ion in root vegetables and salmonella milk, presence of salmonella in milk samples. These are few of the examples of fluorometric and calorimetric nanosensors. So there are different target analytes, salmonella, E. coli, which helps in detection of them. Then recognition elements are there, antibodies, DNA, and then nanomaterials that are used in that. Like
Answeet?
Yes, sir.
Your 8 minutes are up.
Oh, okay, sir.
You can conclude now.
Sir?
You can conclude now.
Okay, sir, but there was more that I wanted to show. Can I just complete it, sir?
Yeah.
How many slides you have?
Sir, I think 5 or 6 slides are remaining.
No, I think because of this, it has already been given the time limit.
Last slide.
Yeah,
Okay,
so
sir.
last slide and conclude that one.
Okay, sir. Okay. So basically, the last slide talks about nano coating. So since edible nano coatings are available on fruits, vegetables, they act as a barrier for moisture and gaseous exchange. So these are done with the help of nano emulsion. By dipping the fruits or vegetables in nano emulsions, these can be act as barrier. So these are few examples. Like bioactive substances and what is their function and what are the food products in which they can be work as nano coatings, and what are the findings that have been done, like carvacrol. It acts as a antimicrobial in cabbage, so it helps in prevention of inhibition of E. coli on cabbage and in nutrient broth. So these are few examples that nanotechnology has shown, especially if we talk about nano coatings. So these were all the things that I have covered, sir. Thank you, sir.
Okay. Good evening, everyone. My name is Sandesh Suresh Kalkar. I am a PhD scholar from CSIR CFTRA, and I am going to talk about non-thermal processing of food. So before we get into the topic, the non-thermal processing of food.
Share the slide. Can you share your?
Okay.
Why does the
Sandesh, you can go ahead. Everything is full screen now.
Is it visible, ma'am? Yeah, okay, fine. So good evening, everyone. My name is Sandesh Suresh Karkad. I am a PhD scholar from CSIR CFTRA, and I'm going to present. I'm going to talk about the non-thermal processing of food. So before we get into the topic, the non-thermal processing of food, we'll just start from what is food processing. Then what are the traditional food processing techniques followed? What are the limitations, and why we require non-thermal processing of food? So food processing is nothing but the methods which we use to convert the raw food materials to a consumption form. Okay, and the main objective is to enhance the bioavailability of the nutrients and also to increase the shelf life of the foods. So there are different types of traditional food processing techniques which have been followed. Some of them are which we carry out at our home also, such as soaking and malting and all we carry out at home. Fermentation also we carry out at home, some of the minor fermentations, and dehulling. There is mechanical processing also where we use mortar and pressors, and there are in industry level there are thermal processing methods, and also there are other techniques such as canning and modified atmospheric packaging techniques. So in industry level, the most commonly preferred is thermal food processing techniques, and there are different types of thermal food processing techniques such as ohmic heating, where we use electricity to heat the food; dielectric heating, where we use radio waves to heat the food; microwave heating, where we use microwave. So we have got microwave ovens where we cook the food through microwave also; pasteurizations, especially in milk industry; infrared heatings, and using infrared radiation; inductive heating, where we use electromagnetic induction principle to heat the food; sterilization and blanching. So these techniques have got advantages and disadvantages too. What are the advantages? The advantages is that the micronutrients are bioavailable, and these are low cost work, and home processing techniques also, some of these techniques. Whereas the disadvantages are these thermal processing techniques, most of them brings about changes in the texture of food, They also affect the organoleptic characteristics of the food. Also, there is a loss of heat-sensitive nutrients, such as mainly vitamins, and also there is a formation of heterocyclic aromatic compounds, which may be proved to be carcinogenic. So, currently, the global consumer demand is towards food with good nutritional quality and excellent texture and mouthfeel, that is with good organoleptic characteristics. So, since these traditional food processing techniques have got the drawbacks, we need an alternative. So we need to substitute these food processing techniques with the new one. So what can be the new good alternative? The good alternative can be the non-thermal food processing techniques. So what are these non-thermal food processing techniques? In thermal food processing techniques, we use heat we use heat treatment. Yes, but in non-thermal, we don't use any heat. That's why the name non-thermal food processing techniques. And moreover, these techniques are considered to be safe and eco-friendly. And this requires low temperature and sometimes low pressure also. And the different types of non-thermal food processing techniques which have been studied so far are pulse electric field, pulse ultraviolet technology, ozone treatment, then ultrasonication, cold plasma technology, irradiation, high hydrostatic pressure, and supercritical fluid technology. So we are going to go through these one by one. So first, let's come across pulse electric field. So what is this pulse electric field? So pulse electric field is nothing but it uses electric pulse of high intensity electric field. So the food material is placed between the electrodes, that is between a set of electrodes, and high intensity electric field is applied in the form of pulse. So there will be a pulse generator which generates the pulse, and usually the intensity of electric field will be around like 25 to 85 kilovolts per centimeter. And this technique is generally more applicable for liquid and semi-solid food. For solid food, it won't be that much applicable. Then this is we can see that schematic figure of the PF operation, where we got here the treatment chamber also. And based on the static and continuous treatment, there are different types of treatment chambers. We can see that parallel type and coaxial type and co-field type, where we let the sample to enter through one side, and after treatment it goes to other side. And pulse electric field, the treatment is usually given for milliseconds, and recently they started pulse electric treatment for food for up to nanoseconds. Now, what are the applications of pulse electric field? Obviously, pulse electric field application of pulse electric field will bring about the reduction of microbial load in the food samples. The reduction is mainly due to the electroporation. This when pulse electric, when the food is subjected to PF treatment, the pulse electric field, it results in the formation of pores in the microbial cell, where the microbial cell loses its intracellular components and it becomes inactive. Apart from this pulse electric field are also been used for the extraction of bioactives from food materials, and they have also found to increase the physical and chemical properties of various food components such as polysaccharides and proteins. Even it increases the reaction rates of esterification and chelation reactions. Okay, now let's move on to another technique. This is another interesting technique, this pulse ultraviolet technology. So in this pulse ultraviolet technology, we use the pulse of ultraviolet radiations. But this is different from this one, electric fields, because here ultraviolet radiations are used. So, and even the ultraviolet radiation which are used are grouped as UVA and ultraviolet A, ultraviolet B, that is UVB, and ultraviolet C, that is UVC. That ultraviolet ray ranges from 320 to 400 nanometer. Ultraviolet B radiation ranges from the 280 to 320 nanometer of the electromagnetic spectrum, and ultraviolet C ranges from 200 to 280 nanometer of the electromagnetic spectrum. So how it brings about the inactivation of microorganisms, we can see here. UVA and UVB radiations, this acts on the microbial cell membrane and generates the reactive oxygen species, which brings about the deterioration of the membrane lipids. So, and in this case, hence, there's a formation of pores and the loss of the intercellular components of the microorganisms, and hence the microorganisms die. Whereas in UVC radiation, the mechanism is quite different. It directly acts on the nucleic acids and results in the formation of mutation. And the type of mutation is dimer formation, pyrimidine dimer formation. You see here the thymine is a pyrimidine, and we can observe the formation of the thymine dimers by the treatment of UVC radiation. And here we can see the representation schematic figure of the pulse UV treatment chamber, where the food has to be placed in the chamber, and the UV radiation is generated and treated onto the food. So, what are the applications of this pulse UV treatment? So this brings about the inactivation of the pathogenic microorganisms, and these are also applicable for most of the liquid food materials such as milk products, and even for fruit juices and all. But for solid food products, this is less preferable because because of the uneven texture, and if the surface is rough, this ultraviolet radiation cannot penetrate deeper into the food material. Hence, this has a limited application. And moreover, recently the scale-up study have also confirmed that this technique is this non-polymer process technique is eco-friendly and is cost-effective. And this can also increase the shelf life of the food. And also, this technique also enhances the physical and chemical properties of proteins in the food. Also, this can increase the antioxidant contents in the food, and also it helps to reduce the toxins in the food. Now, moving on to the next technique, high hydrostatic pressure. So here the name itself indicates the word hydro means we require water. Why we require water? To apply the pressure to the food which has to be treated. Okay, so this is the technique in which we use pressure for the treatment of the food, and the pressure is applied in the range of 200 to 700 megapascal. So this high hydrostatic processing is applicable against wide array of microorganisms, such as even for gram-negative bacteria. It is also bring about destruction of gram-positive bacteria. It can also be applied, can inactivate the yeast and also molds. But the thing is that for gram-positive bacteria, it requires higher pressure, more than 1000 megapascals. So this has got very good applications in the food industry. It can be used for the inactivation of microfilm for a wide range of food, like such as for solid food also, and even for dairy products and liquid food also. So, and even this technique have also been proven to be useful for the extraction of the various biomolecules, such as even in the extraction of antioxidants, even the extraction of pigments such as anthocyanin, extraction of phenolic compounds and all from the food. And also this technique have been proven to enhance the antioxidant and phenolic bioactive and functional components from the various sources. The next technique is a supercritical fluid technology. Now, what is a supercritical fluid? So if any fluid, if they take any fluid, it has a particular critical temperature and critical pressure. So if it is heated beyond that critical temperature and critical pressure, it reaches a supercritical condition, and this is known as supercritical fluid. So most widely used supercritical fluid in the food industry is supercritical carbon dioxide, because it can attain supercritical state at 31.1 degrees Celsius temperature and around 7.4 megapascal pressure. Other than supercritical carbon dioxide, supercritical water have also been used for in food industry. Whereas other supercritical fluids such as supercritical methanol, supercritical ethanol are less favored. So here you can see the phase diagram. And phase diagram, we can observe the three phases. That is the sublimation phase and fusion phase. Yes. Yes, ma'am.
Time is up.
PhD student doing food biotechnology from Department of Food Engineering and Technology, ICT Mumbai. So I'll be presenting on the topic of role of gut microbiota in human health and wellness. So I'll be talking about the microbiota in the healthy gut, followed by the functions of the gut microbiota, and thereafter the diseases that can happen with respect to the type of gut microbiota present in the human body. And later we will discuss about the interrelation of food and the gut bacteria and its impact on the overall health. So talking about the composition of healthy gut microbiota, so specifically strict anaerobes are basically, there are much more in a typical gut microbiota, and which are generally outnumbered by facultative anaerobes and aerobes. So we can say that strict anaerobes are more in number on comparison to facultative anaerobes or aerobes. Apart from it, there are more than 50 bacterial phyla which are present in gut, healthy gut. However, among these 50 bacterial phyla, only 2 phyla are dominated, which are bacteroides and firmicutes. Now talking about the development of a healthy gut microbiota. So basically, as we all know, that in a newborn baby, the GI tract and the gut, the microbiota is generally sterile, and just after the birth, the initial colonization begins. And the point to be noted here that the type of gut microbiota which is going to be developing in the gut of a newborn baby depend on various factors. So as we can see in this diagram over here, that for example, the mode of delivery, it is one of the factors that determines the type of gut microbiota. For example, it is being stated in various studies that if the mode of delivery is cesarean or by surgical method, the gut microbiota are generally more in number on comparison to a normal surgery. Apart from it, various other factors such as the group B streptococcus status, then antibiotics are again certain factors that affect and determine the type of gut microbiota which are present in the human body. So after the initial colonization, based on these factors, in the following weeks, the microbiota starts to develop, and it remains stable for the first few weeks. And as the baby grows, as the body develops, the microbiota start to diversify. Now talking about the functions of the gut microbiota, so the gut microbiota is responsible for carrying out various functions. Among these functions, there are 3 major important functions. So the first one is regulation of metabolism, followed by the host protection and the development of immune system, and at last, gut-brain axis. So talking about metabolism, the role of gut microbiota in the metabolism. So going in detail, the metabolism by gut microbiota, it first of all is responsible for producing various vitamins along with certain essential and non-essential amino acids. Apart from it, the gut microbiota is also responsible for carrying out the biotransformation of the bile juice in the gut. Apart from it, the gut microbiota is also responsible for carrying out the biological pathways for the metabolism of different non-digestible carbohydrates. So that's why we are saying that gut microbiota is responsible for the metabolism of the body, because it is converting the non-digestible carbohydrate and producing energy. And at last, it also helps in the recovery of energy of the host. The another function is the protection of the host and the development of immune system and development. So basically, gut microbiota, as we all know, are responsible for producing bacteriocins. So these bacteriocins are responsible for carrying out anti-microbial effects. Then apart from it, the gut microbiota also exhibit barrier and competitive exclusion effects. So in this effect, as the name is itself suggesting, that the gut microbiota exhibit itself as a competitor of the pathogens, and it try to fit itself in these specific sites where a pathogen can come and exhibited properties. So in that way, gut microbiota exists a barrier, or what we can say a competitive exclusion effect. Apart from it, gut microbiota produce short chain fatty acids, which in turn confer the production of the GI barrier integrity against the cytokines. Apart from it, the TLR, that is toll-like receptors, are also produced by gut microbiota, which help to maintain the gut microbiota host symbiotic relationship and even maintaining the intestinal homeostasis. Now, apart from it, the next function is the gut-brain axis, and the recent studies have are very much inclined toward this concept, where gut-brain axis has been described by the researchers. So, in this concept, basically, it is a communication between. It is a communication system between the gut and the brain. So basically, the gut microbiota sends signals to the brain, and it allows for the basic immunological signaling between the gut as well as the brain. Apart from it, it also allows the intestinal microbiota to access the brain. So as we simply see that it is a system from brain to gut, so it is a bi-directional system, and it also enables the brain to command the immune as well as GI function. For example, peristalsis and the production of mucin, it is being regulated by gut microbiota. Now, talking about the role of gut microbiota in diseases. So as we all know that gut microbiota is very essential for carrying out these functions which we just now studied. So what happens is that if the diversity of the gut microbiota is altered, that particular concept is called as dysbiosis. So in dysbiosis, basically, there is a decrease in the microbial diversity and there is an increase in the pro-inflammatory species. So in this way, there is an imbalance in the microbiota of the healthy gut, and this imbalance is basically responsible for causing diseases. So as we can see in this diagram over here, there are various factors which are responsible for causing this dysbiosis or this imbalance. For example, the type of diet is responsible for causing, for example, if the diet is not proper. Similarly, the sanitation, if the hygiene is not proper, there can be, ultimately there can be development of a disease. Apart from these environmental factors, there are also certain host factors, or what we can say genetic susceptibility factors. For example, the immunity and the inflammation regulation of an individual body. Similarly, the microbes recognition and the mucosa barrier function of an individual human body, it varies from person to person. So these factors are also responsible for carrying out the dysbiosis of gut bacteria. So as the imbalance in the gut occur, so this ultimately leads to the alteration in the immune response, and thereafter there can be n number of diseases. So there can be different diseases. There can be GI related diseases, for example, irritable bowel syndrome, inflammatory bowel diseases. There can be certain normal diseases, for example, type 2 diseases or Crohn's diseases, and there can be also allergy related diseases and various allergic diseases. So talking in detail about these gut microbiota in diseases. So as we just now said, that there is a association between the type of gut microbiota and the diversity. So we can say that there is an association between the reduced diversity and the disease. So overall, we can conclude that a species-rich gut ecosystem, it is generally more robust to the environmental factors on comparison to a less diversified or less species gut, because a healthy or a diversified gut is generally considered as a healthy gut, because if there are more number of bacteria or more number of microorganisms in the gut, they can replace the function of another microorganism which is not present in that human gut. So as we can see in this diagram over here, so these red are the factors which can lead to the formation of a disease. For example, if the sugar intake is very high and there is an alteration in the pH of a particular food, it can eventually lead to certain factors. For example, there can be increase in the lipopolysaccharide production. There can be increased risk of coronary vascular diseases. Similarly, if there is these boxes in blue represent the good factors. For example, if a person is taking a good amount of probiotic and a good amount of dietary fibers, so in that case there can be good results. For example, there can be high antioxidant production, there can be improved lipid metabolism, so there can be, so ultimately there will be a healthy gut. So these are the different factors that we were referring for the gut microbiota in a disease. Now talking about the interrelation of food, gut microbiota and health. So as we just now discussed that there are various factors which are responsible for maintaining a good health of gut. So among those factors, diet and the type of food is the first and the foremost factor that we should take into consideration. So among food, functional food is a type of food which is recently very being important. And when we are talking about functional foods, the three most important functional ingredients are probiotics, prebiotics, and polyphenols. So probiotics, as we all know, are the live microorganism which when are ingested in a confer in an adequate amount, they confer health benefits. So probiotics, particularly in gut, are responsible for exhibiting various functions, among which they are responsible for improving the host health by immune function accumulation. So what they do, they are responsible for increasing the mucosal barrier function. Similarly, they increase the mucosal antibiotic production, and in this way they strengthen the epithelial integrity and basically the direct antagonism of the pathogen. Talking about the another ingredient of functional food, it is prebiotics. So prebiotics are generally the non-digestible carbohydrates, generally belonging to the category of oligosaccharides, and prebiotics are basically a source of food to probiotics. So probiotics are basically the food for probiotics, and again they are also responsible for exhibiting various health effects to the body. For example, they are responsible for producing short chain fatty acids and lactate. They are also responsible for carrying out the bile acid metabolism. Apart from it, they also prevent the pathogen invasion, and apart from it, they are also responsible for absorption of various minerals, for example, calcium, magnesium, and iron. Now talking about polyphenols, polyphenols are again a very new ingredient which is coming into the industry as a very smart functional food ingredient. So polyphenols are basically naturally occurring micronutrients which are derived from plants. And polyphenols, they are known for their antioxidant effects along with their anti-inflammatory effects. And talking about the gut, basically polyphenols are responsible for modulating the gut microbiota by the help of intestinal inflammatory response. So apart from these three functional food ingredients, there is another ingredient that is a symbiotic system. So symbiotic system or symbiotic foods are basically food with a combination of both probiotic as well as prebiotic ingredient. So a food which is having the synergistic effect of both probiotic as well as prebiotic can be referred to as symbiotic food product, and it can exhibit the synergistic effect of both the above two mentioned ingredients. So as we can see in this diagram over here, that how different dietary elements can have a positive impact on the gut microbiota. For example, talking about fiber and prebiotics, they particularly affect the gut microbiome by increasing the microbiota diversity and by producing short chain fatty acids. Similarly, talking about polyphenols, particularly derived from tea, coffee, or vegetables, they are responsible for increasing the intestinal barrier protectors. They are also responsible for butyrate producing bacteria, and they're also responsible for decreasing the liposaccharide producers. Similarly, there can be different type of diets. For example, there can be a vegan diet, and there can be a low FODMAP or we can say food map diet, which is basically used by the healthy consumers for reducing the different gut associated diseases. So overall, we can say that gut microbiota, it is an essential part of human body, and it is generally being considered as a lost organ, and it is not basically considered as an organ. However, it is a very important part of a human body, and in a diverse, healthy microbe in the gut, it is responsible for exhibiting different functions, which we discussed. For example, for maintaining the proper immune system as well as the gastrointestinal tract integrity. However, there can be penetration infection by different pathogens that can result in the various diseases, or there can be different factors that can affect the integrity or the homeostasis of the gut. So that's why there should be proper dietary intervention, for example, supplementation of diets with probiotics, prebiotics, symbiotics, or polyphenols with the help of fermented food products and functional food products in order to maintain the integrity of the healthy human gut. So these are the references which I used. So this was all about my presentation. Thank you. Is it visible?
Yes, it is. Yes.
Ma'am, is the slides moving?
Yes, they are moving. You can start from the beginning.
Okay, sure. Very good afternoon to everyone present here. This is Divya Agarwal. I am a student of Master of Science Food Technology, coming from Central Food Technological Research Institute, that is CSIR CFTRI, based at Mysore, Karnataka. So today, the topic for my presentation would be nanotechnology, the principles and applications in food science. When we talk about what is nanotechnology, it is actually a multidisciplinary tool that encompasses various domains of science, including physics, chemistry, biology, engineering, material sciences, and of course, food technology is the one. What does nanotechnology actually means is the term nano. It refers to the 1 billionth of a meter. We can imagine a human hair that is around 50,000 to 100,000 nanometers in width. Moreover, when we talk about a regular paper A4 sheet, it also is around 75,000 nanometers in thickness. That's what we can make out what 1 nanometer stands out. And the term nanotechnology in itself means that here we study about the phenomena of different materials at different levels with respect to atomic, molecular, and macromolecular. The range includes 1 to 100 nanometers. The picture here represents the different regions in which water, glucose, antibody, and different things align with respect to their sizes. The nano devices range between 1 to 100 nanometers. When we talk about the applications of nanotechnology, it has recently made an appreciable contribution in the field of food science. Talking about the materials, there are various nanomaterials, nanocomposites being used in food science and technology for the manufacturing of various products. Processing involves different unit operations. Drying, freezing, heat and mass transfer is one of the unit operation. When we talk about the packaging of the product, which is basically ensuring the containment, protection, convenience to the consumer in every aspect. Of course, the food safety and quality are the two important elements when we talk about biosecurity. There are different nanosensors and tracers available in today's era that demonstrates the traceability of foods from producer to the consumer. When we talk about nanoemulsions, these categorized under the processing of the food products. Basically, emulsion is a heterogeneous dispersion of two immiscible phases that can be water in oil or can be oil in water. These are stabilized by the addition of surfactants, co-surfactants, and emulsifiers that maintain the stability of the emulsions. When these are broken down into very small size particles, these form into nanoemulsions. The picture right shows that the appearance of emulsion in respect to the size of the globules formed after homogenization, and in the nanoemulsion, it is very comparable. The transparent appearance of the oil of the emulsion made out of oil and water shows that the
the size of the globules is very small and how it can be homogenized properly. There is a study being conducted in 2016 that shows that nanoemulsions can basically be applied in various categories with respect to the delivery systems, as there is a nano encapsulation of bioactive compounds in the foods itself, which can be loaded in the foods and can be obtained in the regular foods like mayonnaise and creams. These can also be used as excipient foods, wherein these are not incorporated in the foods directly, but they're consumed along with the regular foods, so that the bioavailability of the nutraceuticals and the bioactive compounds are achieved, and increasing the bioavailability in the gastrointestinal tract releases a good food matrix design in itself. Also, there are certain good companies in the domain like Nestle and Unilever. They have recently claimed that they have come up with ice creams that can reduce fat levels from 16 to 1% by weight, ensuring the creamy texture of the ice creams. The next comes to the food packaging. Food packaging definitely plays an important role in ensuring the safety of the product. These are divided into 4 major dimensions, that is improved, active, smart, and bio-based packaging. Improved packaging generally indicates the incorporation of nanomaterials to ensure the improvement in physical properties with respect to temperature, moisture barrier, gas barrier, and physical stability, mechanical strength, and durability of the material. Active packaging is yet another dimension that incorporates nanomaterials, but also in addition to the antimicrobial, antioxidative, and UV absorbance properties to enhance the antibacterial properties of the food material so that the shelf life of the products can be increased. The incorporation of nanosensors yet create another dimension called smart packaging, which monitors the condition of the food from farm to fork in respect to the pathogen indicators and the freshness of the food maintained throughout the supply chain. The bio-based packaging incorporate bio-nanomaterials that improve packaging properties like biodegradability, biocompostability, and these are the eco-friendly materials that degrade very easily. Starting with active packaging. Active packaging utilizes various materials with respect to natural extracts obtained from herbs, spices, and different other food commodities. Polymers like chitosan extracted from fish shells waste. The various fungicides, bacteriocins like niacin obtained from Lactococcus lactis, a bacteria. Then again, enzymes, lysozyme, which is an antibacterial enzyme found in dairy products. Organic acids like benzoic acid, sorbates, nanoparticles including silver and zinc oxide. These increase the antimicrobial property of the films. There was a study that showed that the nanocomposite films they ameliorated the effect of the shelf life of fresh cheese. It was observed that on increasing the concentration of silver nanoparticles, a decrease in water vapor permeability was observed. Moreover, these films exhibited strong antimicrobial activity against different microorganisms, including E. coli, Salmonella species, and Penicillium species. As can be seen from the graph, the dark black line indicates the control sample, whereas the dashed light line indicates the nanocomposite package, which could maintain the shelf life of a fresh cheese samples for more than 21 days when compared to the control sample. When we come to smart packaging, obviously, if it would be unfair if we don't talk about CFTRI here. There was a study which was being published in Indian Journal of Advances in Chemical Science. A lactic acid based spoilage indicator was developed for the evaluation of milk based commodities. An irreversible color change of indicator, that is, if the milk is fresh, it will remain light green, and as the milk is prone to spoilage, it will turn into orange and then dark red. That progressively gives the indication of spoilage. These are used as external and internal indicators, but in the study, when this indicator was incorporated in the film packet, it was based on the unidirectional permeable membrane that focuses on the direction that allows only one direction passing from milk to the indicator, not the other way. That prevents the migration of any compound to the milk. In such a case, that monitors the quality losses of the food. The next talks about bio-based packaging. The recent study that was released in 2020, it involves the basic tulsi extract from, it was obtained from CFTRI campus itself. The seeds of this Ocimum basilicum was employed for the preparation of certain bio-based packaging films with the utilization of certain nanofillers like MMT. The films were prepared by the general solvent casting method at various variables of pH and percentage of nanofillers. When it was evaluated for different physical, mechanical, and barrier properties, it was found that. Sorry, ma'am. Yes, ma'am.
Your time is over. 8 minutes over. How many more slides you have?
So 2 more slides and it's done.
Okay. Conclude now. You can conclude now. Huh?
This was again the traceability, talking about farm to fork, as there are various cases of adulteration noted from the point of animal based products, wherein they use very cheap commodities to market their products. In such a case, nanotechnology plays a role in presenting RFID tags and barcodes with different sensors, which ensure the authenticity and biosecurity protection for the food materials. There are certain benefits associated with nanotechnology, as mentioned before. Various studies indicate that the products have extended their shelf lives and the quality and freshness of the products are being remained. Whereas it comes along with certain risk involving potential human health concerns due to the utilization of general nanoparticles. The conclusion and the future implications lies in, as the world is now grappling up with a very devastating disease of COVID-19 pandemic. Nanotechnology here also plays an important role in preventing such things. Recently, I was listening to a podcast where it was mentioned that there are various clothing materials developed from nanotechnology that prevent the viruses entering inside. The future scope for nanotechnology in food direction is developing more and more. The direction is to develop more nanomaterials to incorporate into food products and maintaining the organoleptic properties. So this is from my side. Thank you.
Hello everyone. Good evening. These were the videos that needs to be So, ma'am, all the videos are played. Can we close the session? And without